20 space megastructures could exist in the universe, and one day, humans might be capable of constructing some of them. For example, colony starships. Colony starships represent one of the most ambitious and exciting concepts for the future of humanity in space. These enormous spacecraft would be designed to carry large populations on long-duration missions, with the goal of establishing human colonies on distant planets or even in other star systems. Unlike the shorter trips undertaken by current space missions, colony starships would need to sustain their inhabitants for years, decades, or even centuries as they travel through the vast expanses of space. The successful development and deployment of such starships could play a crucial role in humanity's long-term survival and expansion beyond Earth. A colony starship would work as a self-sustaining closed-loop environment, essentially functioning as a small artificial world. It would be equipped with advanced life support systems that recycle air, water, and waste to maintain a stable and habitable environment for its passengers. These systems would need to be highly efficient and reliable, given the isolated nature of the starship and the impossibility of resupplying from Earth during its journey. Food production would be handled on board through hydroponic or aeroponic farming systems, where crops are grown without soil, using nutrient-rich water or mist. This would ensure a steady supply of fresh food for the crew and passengers. One of the key challenges in designing a colony starship is providing artificial gravity to counteract the effects of long-term weightlessness on the human body. One solution is to build the starship in a rotating design, where centrifugal force would create gravity-like conditions on the inside of the rotating sections. This would allow the inhabitants to walk, live, and work in an environment similar to Earth's, preventing the muscle and bone loss that occurs in microgravity. This rotating section could be designed as a large ring or cylinder, with living quarters, workspaces, and recreational areas built into the inner surface. In addition to its physical infrastructure, a colony starship would need to address the social and psychological needs of its inhabitants. Living in a confined space for extended periods can be challenging, so the starship would be designed with diverse and adaptable habitats that simulate natural environments, such as parks, forests, or even simulated weather patterns. Entertainment, education, and social interaction would be facilitated through advanced virtual reality systems, allowing passengers to stay connected with each other and with life on Earth. Psychological support and community building would be critical to maintaining the mental well-being of the starship's population. The benefits of colony starships for humanity are profound. First and foremost, they offer a way to ensure the long-term survival of our species. Earth is vulnerable to various existential threats, including natural disasters, pandemics, and potentially even man-made dangers like nuclear war or climate change. By establishing colonies on other planets or in other star systems, humanity would reduce its dependence on a single planet, ensuring that our species could continue to thrive even if Earth were to face a catastrophic event. Colony starships also hold the promise of expanding human civilization across the cosmos. By venturing beyond our solar system, we could discover new worlds with untapped resources, unique environments, and possibly even extraterrestrial life. This would open up new opportunities for scientific discovery, cultural exchange, and economic growth. As humanity spreads to new frontiers, we would carry with us the knowledge, culture, and diversity that make our civilization unique, creating new societies and ways of life in distant parts of the galaxy. In the future, colony starships could also serve as the foundation for a spacefaring economy. These starships could establish trade routes between Earth and newly colonized planets, exchanging goods, technology, and information across vast distances. The development of these starships would drive advancements in propulsion technology, material science, and space infrastructure, with benefits that could be applied to other areas of space exploration and industry. The ability to travel and trade between star systems could lead to a new era of economic growth and innovation, with humanity taking its place as a multi-planetary civilization. Make sure to stick around to the end because this video explores Dyson spheres, O'Neill cylinders, ring worlds, planetary shields, wormholes, and more. Number 2. Dyson swarms. A Dyson swarm is an ambitious concept that could revolutionize humanity's approach to energy generation by harnessing the immense power of the sun. Unlike the more well-known Dyson sphere, which envisions a solid shell surrounding a star, a Dyson swarm consists of a vast number of individual satellites or solar collectors that orbit the star in a coordinated pattern. These satellites would capture a significant portion of the star's energy output and convert it into usable power, potentially providing near-limitless energy for humanity's needs. The idea behind a Dyson swarm is to create a distributed network of solar collectors that can be gradually expanded over time. Each satellite in the swarm would be equipped with advanced solar panels that capture sunlight and convert it into electricity. This energy could then be transmitted back to Earth or other locations in the solar system using wireless energy transfer technologies such as microwave beams or lasers. The modular nature of a Dyson swarm allows for flexibility in its construction because additional satellites can be added incrementally, each contributing to the overall energy output. One of the primary benefits of a Dyson swarm is its potential to solve humanity's energy challenges. By capturing even a small fraction of the sun's energy, a Dyson swarm could generate more power than all of Earth's current energy sources combined. This abundant energy supply could support the growing global demand for electricity, enable the widespread adoption of renewable energy, and provide the power needed for advanced technologies like artificial intelligence, space travel, and large-scale computing. In addition to meeting Earth's energy needs, a Dyson swarm could also support future space exploration and colonization efforts. The energy harvested by the swarm could power spacecraft, habitats, and other infrastructure in space, making it easier to establish colonies on the Moon, Mars, and beyond. This energy could also be used to fuel advanced propulsion systems, enabling faster and more efficient travel between planets and potentially even to other star systems. The availability of abundant energy in space would be a key enabler for humanity's expansion into the cosmos. Another significant advantage of a Dyson swarm is its potential to mitigate the environmental impact of energy production on Earth. By relying on the sun's energy, humanity could reduce its dependence on fossil fuels and nuclear power, which have associated risks and environmental consequences. A Dyson swarm could help reduce greenhouse gas emissions, slow climate change, and decrease pollution, contributing to a more sustainable and environmentally friendly energy future. Building a Dyson swarm would also drive technological innovation and create new industries. The construction of such a massive and complex structure would require advancements in materials science, robotics, and space manufacturing. Automated systems and self-replicating machines could be developed to construct and maintain the swarm, reducing the need for human intervention and making the process more efficient. The technologies developed for a Dyson swarm could have applications beyond space, benefiting industries on Earth in areas such as energy, telecommunications, and manufacturing. Moreover, the concept of a Dyson swarm aligns with the long-term vision of humanity becoming a Type II civilization on the Kardashev scale, a society that can harness the energy output of an entire star. Achieving this level of technological and energy capability would represent a significant milestone in human progress, enabling us to address global challenges more effectively and pursue more ambitious goals, such as interstellar exploration and the search for extraterrestrial life. Number 3. O'Neill cylinders. O'Neill cylinders are a fascinating concept for space habitats that could one day provide a home for millions of people beyond Earth. Proposed by physicist Gerard K. O'Neill in the 1970s, these gigantic cylindrical structures would rotate in space to create artificial gravity on their inner surfaces, allowing people to live and work in a comfortable, Earth-like environment. O'Neill cylinders are envisioned as a solution to overpopulation, resource scarcity, and the challenges of sustaining large human populations in space, making them a key element in humanity's future as a spacefaring civilization. Jeff Bezos has also proposed this megastructure as a viable solution for the future. An O'Neill cylinder would work by using centrifugal force to simulate gravity. The cylinder, which could be as long as 20 miles and several miles in diameter, would rotate around its central axis. This rotation would push everything inside outward toward the inner surface of the cylinder, creating a gravity-like effect that would allow people to walk, live, and build as they would on Earth. The inner surface of the cylinder would be divided into different zones, with some areas dedicated to cities, others to agriculture, and still others to natural landscapes. Large windows made from transparent materials would allow sunlight to enter, providing natural light and enabling photosynthesis for plants. In addition to providing living space, O'Neill cylinders could be a hub for advanced industry and research. The microgravity environment outside the cylinder, combined with the controlled environment inside, would make it an ideal location for manufacturing high-tech materials, pharmaceuticals, and other products that are difficult to produce on Earth. Research facilities in O'Neill cylinders could also conduct experiments in fields like physics, biology, and material science that take advantage of the unique conditions in space. This could lead to new discoveries and innovations that benefit both the inhabitants of the cylinder and people on Earth. O'Neill cylinders could also play a crucial role in the colonization of the solar system. Positioned in orbit around Earth, the Moon, or other planets, these cylinders could serve as way stations for missions to Mars, the asteroid belt, and beyond. They could provide a base of operations for mining asteroids, extracting valuable resources such as metals and water, and processing them into useful materials. The resources gathered from space could then be used to build more O'Neill cylinders, further expanding humanity's presence in the solar system and creating a self-sustaining cycle of growth and development. Another key benefit of O'Neill cylinders is their potential to create a more sustainable and equitable society. The controlled environment of the cylinder would allow for the implementation of advanced agricultural techniques such as vertical farming and hydroponics, which could produce food more efficiently and with less environmental impact than traditional farming methods. The abundance of solar energy in space could be harnessed to power the cylinder, providing a clean and virtually limitless source of energy. These factors, combined with the vast living space available, could enable the creation of a society that is less dependent on finite resources and more focused on sustainability and long-term well-being. In the future, O'Neill cylinders could also become cultural and educational centers, preserving and promoting human knowledge, art, and traditions. As humanity spreads across the solar system, these cylinders could serve as repositories of culture and history, ensuring that our shared heritage is not lost as we explore new worlds. Educational institutions within the cylinders could provide training in the skills needed for life in space, preparing future generations for the challenges and opportunities of a spacefaring civilization. Number 4. Planetary shields. A planetary shield is a visionary concept that could play a crucial role in protecting Earth or other planets from a range of potential threats, both natural and artificial. This immense structure, or series of interconnected structures, would be designed to shield a planet from hazards such as asteroid impacts, solar radiation, space debris, and even hostile attacks. By acting as a protective barrier, a planetary shield could safeguard the inhabitants of a planet, ensuring the continuity of life and the stability of the environment. The concept of a planetary shield could be realized through several different technologies, depending on the specific threats it is designed to counter. For instance, to protect against asteroids and space debris, the shield could consist of a network of high-powered laser systems or electromagnetic railguns positioned in orbit around the planet. These systems would be capable of detecting incoming objects and either deflecting or destroying them before they could reach the surface. The lasers could vaporize smaller debris or alter the trajectory of larger asteroids, preventing catastrophic impacts that could cause widespread destruction. To shield against solar radiation, particularly harmful solar flares or coronal mass ejections, the planetary shield might incorporate large arrays of magnetic field generators placed in strategic locations around the planet. These generators would create a powerful artificial magnetic field similar to Earth's natural magnetosphere, which could deflect charged particles from the sun. This would protect the planet's atmosphere from being stripped away, and shield electronic systems from the damaging effects of intense solar radiation, thereby preventing disruptions to communication networks, power grids, and satellites. In the context of planetary defense against potential hostile attacks, the planetary shield could be equipped with advanced missile defense systems, particle beams, or even a form of energy barrier. These defense systems would be capable of intercepting and neutralizing any threats before they could cause harm. The presence of such a shield could serve as a deterrent, discouraging potential aggressors from attempting to attack the planet. Additionally, the shield could provide a layer of protection for planetary infrastructure, ensuring the safety of critical assets such as space stations, satellites, and spaceports. The benefits of a planetary shield for humanity are profound. One of the most immediate advantages would be the protection of human life and infrastructure from natural disasters like asteroid impacts. Historically, large asteroid collisions have caused mass extinctions and significant environmental changes on Earth. A planetary shield could prevent such events from occurring, preserving the planet's ecosystems and preventing loss of life on a massive scale. This would be particularly important as humanity continues to expand its presence in space, with more satellites, space stations, and potentially colonies in orbit or on other celestial bodies. Beyond protection from natural threats, a planetary shield could also play a crucial role in maintaining global stability in the face of human-made dangers. As space becomes increasingly militarized and the potential for conflicts in space grows, having a planetary defense system in place could prevent catastrophic attacks on Earth or other inhabited planets. This would reduce the risk of large-scale warfare in space, helping to maintain peace and security on a global scale. Moreover, the development and deployment of a planetary shield would drive significant advancements in technology and science. The research and engineering required to create such a shield would lead to breakthroughs in fields such as materials science, energy generation, and space-based sensors. These advancements could have wide-ranging applications, improving technologies on Earth and enabling new capabilities in space exploration. For example, the technology developed for a planetary shield could be adapted for use in protecting space habitats, lunar bases, or Martian colonies, ensuring the safety of humans living and working beyond Earth. In the future, a planetary shield could also support the terraforming efforts on other planets. By controlling and regulating the amount of solar radiation that reaches a planet's surface, the shield could help create more stable and habitable environments. This would be particularly useful in the early stages of colonization, where managing the planet's climate and protecting new settlements from space weather would be critical to the success of the mission. Number 5. Ringworlds. Ringworlds are a fascinating and ambitious concept in the realm of space megastructures, offering the potential to create vast, habitable environments far beyond what is possible on Earth. A ringworld is essentially a massive ring that orbits a star, with its inner surface designed to support life. This ring would be constructed at a distance from the star where temperatures would be suitable for human habitation, creating an artificial world with an area millions of times greater than the surface of Earth. The idea, popularized by science fiction author Larry Niven, could represent the ultimate solution to the challenges of overpopulation, resource scarcity, and the quest for sustainable living spaces. A ring world would work by using centrifugal force to simulate gravity. The entire structure would rotate around its star, with the outer edge of the ring spinning at such a speed that it creates a gravitational pull on the inhabitants and objects on its inner surface. This would allow people to live, walk, and build on the ring's surface as they would on Earth, despite the structure being located in space. The ring's immense surface area would provide ample space for cities, agriculture, and natural environments, potentially accommodating billions or even trillions of people. One of the most significant benefits of a ring world is its potential to solve the issue of overpopulation. With a habitable area far greater than that of Earth, a ring world could support a vast population, providing them with space to live, work, and thrive. This would alleviate the pressures on Earth's ecosystems and resources, allowing for more sustainable development and conservation of the natural environment. The abundance of space on a ring world would also enable the creation of expansive green areas, parks, and natural reserves, enhancing the quality of life for its inhabitants. In addition to providing living space, a ring world could offer unparalleled access to resources. The structure could be designed with advanced technology to harvest solar energy directly from its star, providing virtually limitless power to its inhabitants. This energy could be used to support industries, agriculture, and the overall infrastructure of the ring world, making it largely self-sufficient. Furthermore, the ring world could be equipped with systems to capture and recycle resources, minimizing waste and ensuring the sustainability of the environment. Another intriguing aspect of a ring world is its potential for scientific research and exploration. The unique environment of a ring world, combined with its proximity to a star, would provide opportunities to study astrophysics, planetary science, and other fields in ways that are not possible on Earth. The vast size of the ring world would also enable the establishment of research centers, observatories, and laboratories dedicated to advancing human knowledge. However, the sheer amount of material needed to construct a ring world is staggering. Even if we dismantled every planet, moon, and asteroid in our solar system, it still might not provide enough matter to build such a structure. This is why a ring world is often seen as a far future megastructure, potentially feasible only in another solar system. In the far future, a ring world could serve as a model for future space colonies, enabling humanity to establish a presence across the galaxy and ensuring the continued growth and expansion of our civilization. Number 6. Wormholes. Wormholes are a theoretical concept in physics that could revolutionize space travel by providing shortcuts through space-time, connecting distant regions of the universe in an instant. Often depicted in science fiction, wormholes, if they exist, would function like tunnels with two ends at separate points in space and time. This means that traveling through a wormhole could allow someone to traverse vast distances that would otherwise take thousands or even millions of years to cover using conventional space travel methods. The idea of wormholes originates from Einstein's theory of general relativity, which describes how massive objects warp the fabric of space-time. According to this theory, it is theoretically possible for space-time to be folded or bent in such a way that two distant points touch, creating a shortcut between them, a wormhole. In practice, a wormhole would consist of two mouths connected by a throat, and passing through the throat would instantly transport you from one mouth to the other, regardless of the distance between them in normal space. For wormholes to work as practical transportation devices, they would need to be stable and large enough for spacecraft to pass through. However, one of the significant challenges with wormholes is that they are predicted to be highly unstable. The immense gravitational forces involved could cause them to collapse or close before anything could pass through. Some theories suggest that exotic matter with negative energy density could be used to stabilize a wormhole, preventing it from collapsing and allowing safe passage. The potential benefits of wormholes for humanity are extraordinary. The most obvious advantage is the possibility of interstellar travel in a fraction of the time it would take using conventional methods. Instead of spending decades or centuries traveling to the nearest stars, wormholes could allow for near instantaneous travel between distant parts of the galaxy. This would open up the universe for exploration and colonization, enabling humanity to establish settlements on far-off planets, access new resources, and potentially encounter other forms of intelligent life. Wormholes could also revolutionize communication across vast distances. Currently, communicating with spacecraft or colonies on other planets involves significant time delays due to the finite speed of light. Wormholes could eliminate these delays by providing a direct link between two distant points, allowing for real-time communication across the galaxy. This would be crucial for coordinating space missions, sharing scientific data, and maintaining connections between human settlements spread across different star systems. Beyond their practical applications for travel and communication, wormholes could also provide valuable insights into the nature of the universe. Studying and understanding how wormholes work could lead to breakthroughs in fundamental physics, shedding light on the mysteries of space-time, gravity, and quantum mechanics. The existence of wormholes could also offer evidence for the theory of multiverses, suggesting that there are other universes beyond our own that could be accessed through these cosmic tunnels. The potential for wormholes to connect not just distant points in space, but also different times, adds another layer of intrigue. Theoretical models suggest that a wormhole could link different points in time, potentially enabling time travel. While this idea raises complex questions about causality and the nature of time itself, it also opens up fascinating possibilities for exploration and discovery, allowing humanity to learn more about the history of the universe or even influence future events. In the future, if wormholes were proven to exist and could be safely traversed, they could fundamentally alter the trajectory of human civilization. The ability to travel across the galaxy and beyond would expand humanity's reach, allowing us to explore and settle in regions of space that are currently beyond our grasp. This could lead to the development of a galactic civilization where humanity spreads out among the stars, thriving in multiple star systems and ensuring the long-term survival of our species. Number 7. Matryoshka brains. Matryoshka brains are an advanced and speculative concept in the realm of space megastructures, representing a vision of ultimate computational power. Named after the Russian nesting dolls which stack within one another, a Matryoshka brain would consist of a series of concentric Dyson spheres, each one encompassing the previous layer, built around a star. These layers would be made of advanced solar collectors and computational nodes, allowing the entire structure to harness the star's energy and convert it into an almost incomprehensible amount of computing power. The core idea of a Matryoshka brain is to maximize the use of a star's energy output by capturing it at multiple levels. The innermost shell would be a traditional Dyson sphere, which directly absorbs energy from the star. Surrounding this inner sphere, additional layers would be constructed, each absorbing the energy radiated by the layer beneath it. This process would continue outward, with each successive shell capturing and utilizing energy that would otherwise be lost to space. The outermost layer would radiate minimal heat, making the Matryoshka brain an incredibly efficient system for energy utilization. The computing power of a Matryoshka brain would be virtually limitless. Each layer would be packed with computational nodes that operate at incredibly high speeds, processing information and running simulations on a scale far beyond anything currently imaginable. This immense computational capacity could be used for a wide range of applications, from running detailed simulations of the universe to solving complex problems in science, mathematics, and technology. It could even support the creation of highly sophisticated artificial intelligence systems, enabling the development of entities with intelligence surpassing all humans who have ever lived. One of the most profound benefits of a Matryoshka brain would be its potential to advance scientific knowledge and understanding. With its vast computational resources, a Matryoshka brain could simulate entire ecosystems, weather patterns, or even the universe itself. It could help humanity explore the deepest mysteries of physics, such as the nature of dark matter, the behavior of quantum particles, or the origins of the universe. By running simulations of different scenarios, it could predict the outcomes of various cosmic events, from the formation of galaxies to the evolution of stars. Additionally, a Matryoshka brain could revolutionize the field of artificial intelligence. With its immense processing power, it could support the creation of AI entities with unparalleled cognitive abilities. These AI systems could assist in solving some of humanity's greatest challenges, from climate change to disease eradication, by processing and analyzing vast amounts of data more efficiently than any human could. The Matryoshka brain could also simulate entire societies or virtual worlds, allowing for the exploration of different social, economic, and technological systems in a controlled environment. Furthermore, the potential for digital immortality could be realized within a Matryoshka brain. Humans could upload their consciousness into the structure, effectively achieving a form of digital immortality, where their minds continue to exist and evolve within the virtual environment created by the Matryoshka brain. This could allow individuals to live out multiple lifetimes, exploring different experiences, worlds, and realities in a safe and controlled environment. This concept of mind uploading could fundamentally change the nature of human existence, offering new possibilities for personal growth, learning, and exploration. Number 8. Space elevators. Space elevators are one of the most intriguing and potentially transformative concepts in the field of space exploration. A space elevator would be a giant structure extending from Earth's surface to a point far beyond geostationary orbit, around 22,000 miles above the equator. This structure would enable the transportation of materials, equipment, and even people into space without the need for rockets, drastically reducing the cost and environmental impact of accessing space. The idea, first proposed in the late 19th century, has gained renewed interest as materials science and engineering have advanced, making it a more plausible endeavor in the future. The core of a space elevator would be its tether, an immensely strong and lightweight material that could stretch from Earth's surface to space. The most promising candidate for this tether is carbon nanotubes or graphene, materials that are incredibly strong yet lightweight enough to make the concept feasible. The tether would be anchored to a platform at the equator and extend upward to a counterweight in space, beyond geostationary orbit. This counterweight would keep the tether taut through the centrifugal force generated by Earth's rotation, effectively balancing the entire structure. To travel up and down the space elevator, specially designed vehicles called climbers would be used. These climbers would be electrically powered, possibly through solar energy or beamed power from the ground, and would ascend or descend along the tether. Unlike rockets, which require vast amounts of fuel and generate significant pollution, these climbers would operate more like elevators in a skyscraper, providing a smooth, continuous journey into space. The benefits of space elevators for humanity could be profound. One of the most significant advantages is the potential to dramatically reduce the cost of sending materials and people into space. Currently, launching payloads into orbit using rockets is extremely expensive, often costing thousands of dollars per kilogram. A space elevator could reduce these costs by a factor of 100 or more, making space more accessible for a wide range of activities, from scientific research to commercial ventures. This reduction in cost could spur a new era of space exploration and development, enabling the construction of space habitats, factories, and even space-based solar power stations that could provide clean energy for Earth. In addition to lowering costs, space elevators could also reduce the environmental impact of space travel. Traditional rocket launches generate significant pollution, both in the atmosphere and on the ground, where rocket fuel and other chemicals can cause environmental damage. By using electric-powered climbers, space elevators would produce little to no emissions, making them a far more sustainable option for accessing space. This would be particularly important as the demand for space travel increases, helping to ensure that humanity's expansion into space does not come at the expense of Earth's environment. Another important benefit of space elevators is their potential to enable large-scale construction projects in space. With the ability to transport massive amounts of materials to orbit at a low cost, space elevators could facilitate the building of space habitats, research stations, and even spacecraft. These structures could be assembled in space where there are no gravitational constraints, allowing for the creation of megastructures that would be impossible to build on Earth. This capability could accelerate the colonization of the Moon, Mars, and other celestial bodies, as well as the development of space-based industries that could drive economic growth and innovation. Number 9. Orbital mining stations. Orbital mining stations represent a transformative concept in space exploration and resource acquisition, offering humanity the potential to access the vast wealth of materials available in asteroids, moons, and other celestial bodies. These stations would serve as hubs for mining operations in space, extracting valuable minerals, metals, and other resources directly from these celestial bodies and processing them in orbit. The idea of orbital mining is rooted in the understanding that many of the materials that are rare or difficult to obtain on Earth exist in abundance in space, particularly in asteroids, which are rich in elements like platinum, gold, nickel, and water. An orbital mining station would work by positioning itself near an asteroid or another resource-rich body, such as a moon or a small planet. The station would be equipped with advanced robotics, autonomous mining equipment, and processing facilities designed to operate in the harsh conditions of space. These machines would mine the target body, extracting raw materials and transporting them to the station for processing. Once processed, these materials could be used directly in space, for example, in the construction of space habitats, satellites, or other megastructures, or transported back to Earth for use in various industries. One of the most significant benefits of orbital mining stations is their potential to revolutionize resource availability on Earth. As our planet's population grows and the demand for raw materials increases, the pressure on Earth's finite resources becomes more intense. By tapping into the virtually limitless supply of materials in space, orbital mining stations could alleviate this pressure, providing a new source of critical resources like rare metals and water. This could reduce the environmental impact of mining on Earth, preserving ecosystems and reducing the degradation of natural landscapes. In addition to supplying materials for Earth, orbital mining stations could play a crucial role in the development of space infrastructure. The construction of space habitats, solar power stations, and other megastructures requires vast amounts of material, much of which would be prohibitively expensive to launch from Earth due to the high cost of space transportation. By sourcing these materials directly from space, orbital mining stations could significantly reduce the cost and complexity of building in space, making large-scale projects more feasible. This could accelerate the development of space colonies, research stations, and other facilities that support a growing human presence in space. Moreover, orbital mining stations could contribute to the sustainability and longevity of space missions. Water, for example, is a critical resource for life support systems, as well as for producing rocket fuel through electrolysis. By extracting water from asteroids or moons and processing it in orbit, these stations could provide a reliable and cost-effective supply of fuel and life support resources for missions to the Moon, Mars, and beyond. This would enable longer and more ambitious missions, reducing the need for resupply missions from Earth and increasing the autonomy of spacecraft and space habitats. The economic potential of orbital mining stations is also immense. The value of the materials available in just a single asteroid can be staggering. Some estimates suggest that the resources in certain asteroids could be worth trillions of dollars. By establishing a network of orbital mining stations, humanity could tap into this wealth, driving economic growth and creating new industries centered around space resource extraction and processing. This could lead to the development of new markets, job creation, and technological innovation, further integrating space into the global economy. In the future, orbital mining stations could also support interplanetary trade and the creation of a space-based economy. As humanity expands its presence in space, the need for materials and goods in orbit will increase. Orbital mining stations could serve as nodes in a supply chain that stretches across the solar system, providing the raw materials needed for construction, manufacturing, and life support in space. This could enable the growth of space colonies and the establishment of trade routes between Earth, the Moon, Mars, and other locations, fostering a vibrant and interconnected space economy. Number 10. Penrose spheres around black holes. Penrose spheres are an ambitious and speculative concept in the realm of space megastructures, inspired by the theoretical ideas of physicist Roger Penrose. These structures are designed to harness the immense energy found in the vicinity of a rotating black hole. Unlike traditional energy sources, which rely on chemical, nuclear, or solar power, Penrose spheres would tap into one of the most powerful and mysterious forces in the universe, the rotational energy of a black hole. The basic idea behind a Penrose sphere is to create a massive spherical structure that encircles a rotating black hole, known as a Kerr black hole. The black hole's rotation causes the surrounding space-time to twist in a phenomenon known as frame dragging. This effect creates an ergosphere, a region just outside the event horizon where objects can potentially gain energy by following specific trajectories. A Penrose sphere would be designed to capture this energy by carefully manipulating objects or particles within the ergosphere, extracting energy from the black hole's rotation without falling into it. In practical terms, the Penrose process involves sending material into the ergosphere on a precise trajectory. Once inside this region, the material would split into two parts. One part falls into the black hole, while the other escapes with more energy than it originally had. The escaping material, now energized, could be collected and converted into usable power. By repeating this process continuously, a Penrose sphere could theoretically extract vast amounts of energy from the black hole, effectively using it as a cosmic power plant. The benefits of a Penrose sphere for humanity could be profound. First and foremost, it offers a nearly limitless source of energy. The rotational energy of a black hole is immense, and a Penrose sphere could harness this energy for countless applications. This could provide power not only for space-based infrastructure, such as space stations, habitats, and spacecraft, but also for advanced technologies that require enormous amounts of energy, such as large-scale simulations, artificial intelligence, and even interstellar propulsion systems. In addition to energy generation, Penrose spheres could play a critical role in deep space exploration and colonization. The ability to harness the energy of a black hole would enable long-term sustainable human presence in regions of space far from the sun or other stars. This would allow humanity to establish colonies and research stations near black holes, exploring some of the most extreme and intriguing environments in the universe. The proximity to a black hole would also provide unique opportunities for scientific research, potentially leading to breakthroughs in our understanding of gravity, quantum mechanics, and the nature of space-time. Another intriguing possibility is the use of Penrose spheres in the development of advanced propulsion systems. The energy extracted from a black hole could be used to power spacecraft capable of reaching incredible speeds, potentially even allowing for faster-than-light travel through theoretical concepts such as warp drives or wormholes. This could revolutionize space travel, making interstellar journeys feasible and opening up the entire galaxy for exploration and colonization. The construction of a Penrose sphere would be an unprecedented engineering challenge, requiring materials and technologies that are currently beyond our reach. However, the pursuit of this concept could drive significant advancements in fields such as materials science, energy storage, and space construction. Number 11. Interplanetary relay networks. An interplanetary relay network is a visionary concept designed to enhance communication across the vast distances of our solar system, serving as the backbone for interplanetary exploration, colonization, and commerce. As humanity sets its sights on establishing a presence on other planets and moons, the need for reliable, high-speed communication between Earth and these distant outposts becomes increasingly critical. An interplanetary relay network would address this need by creating a network of satellites, space stations, and ground-based relays that facilitate seamless communication across millions or even billions of kilometers. The concept of an interplanetary relay network revolves around deploying a series of communication satellites in strategic orbits around planets, moons, and other key locations in the solar system. These satellites would be equipped with advanced communication technologies, such as high-frequency radio waves, lasers, or even quantum communication systems, to transmit data at the highest possible speeds. The network would be designed to ensure that signals can be transmitted continuously, avoiding the delays and interruptions that currently occur when spacecraft or planets move out of alignment with Earth. Each relay station in the network would act as a node, receiving, amplifying, and forwarding signals from one location to another. For example, a signal sent from a Mars colony could be transmitted to a satellite orbiting Mars, which would then relay the signal to another satellite positioned between Mars and Earth, and finally to a receiving station on Earth. This relay system would allow data to travel across the solar system with minimal delay, enabling real-time communication and data exchange between Earth and distant space missions. The benefits of an interplanetary relay network for humanity are numerous and far-reaching. First and foremost, it would vastly improve the safety and effectiveness of space exploration missions. Currently, communication delays between Earth and Mars can range from several minutes to over 20 minutes, depending on the planet's relative positions. These delays can hinder mission control's ability to respond to emergencies or guide rovers and spacecraft in real time. An interplanetary relay network would reduce these delays, enabling faster decision-making and more precise control over missions, thereby enhancing the safety and success of space exploration. In addition to improving mission control, an interplanetary relay network would be essential for supporting human settlements on other planets and moons. As colonies on Mars, the Moon, and other celestial bodies become a reality, the need for reliable communication will be paramount. Colonists will need to communicate with Earth for everything from coordinating supply shipments to staying in touch with loved ones. The network would ensure that these communications are as seamless as possible, helping to maintain a strong connection between Earth and its off-world colonies. The network would also be crucial for scientific research and data collection. As space probes, telescopes, and landers explore distant planets, moons, and asteroids, they generate vast amounts of data that must be transmitted back to Earth for analysis. An interplanetary relay network would provide the bandwidth and reliability needed to transmit high volumes of data quickly and accurately. This would accelerate scientific discoveries, enabling researchers to analyze new information in near real time and make groundbreaking advancements in our understanding of the solar system. Moreover, an interplanetary relay network could pave the way for the development of an interplanetary internet, connecting not just Earth, but also multiple planets, moons, and space stations in a vast digital network. This would allow for the creation of new forms of communication, commerce, and collaboration across the solar system. For example, companies could establish interplanetary business operations, researchers could collaborate on projects in real time from different planets, and individuals could access entertainment, education, and social networks from anywhere in the solar system. In the future, the interplanetary relay network could also play a critical role in supporting interstellar exploration. As humanity looks beyond our solar system to explore nearby star systems, the relay network could be expanded to include deep space communication stations, enabling long-distance communication with interstellar probes and potentially even with other civilizations. Number 12. Stellar engines. Stellar engines are a theoretical concept for gigantic space megastructures designed to move entire stars and their surrounding solar systems. The idea is both awe-inspiring and incredibly ambitious, as it envisions humanity gaining control over the movement of stars, effectively steering entire solar systems through the galaxy. While this might sound like science fiction, the concept is rooted in the laws of physics and represents a fascinating exploration of what could be possible in the distant future. A stellar engine would work by harnessing the energy output of a star to generate thrust, gradually pushing the star and everything in its orbit in a specific direction. One of the most well-known designs for a stellar engine is the Shkadov thruster, named after the Russian physicist Leonid Shkadov who proposed it. This design involves constructing a massive reflective structure, such as a giant mirror or a Dyson sphere-like surface, that partially surrounds the star. The structure would reflect a portion of the star's light back toward it, creating a pressure imbalance that would exert a gentle but continuous thrust on the star. Over time, this thrust would accumulate, causing the star to move slowly through space. Another more advanced design is the Kaplan thruster, which combines the principles of a Dyson sphere and a fusion-based propulsion system. In this concept, a large structure would capture solar energy and use it to power a fusion engine that expels high-velocity plasma or other propellant. This expelled material would push against the star, creating a reaction force that moves the entire system. The Kaplan thruster could potentially generate more significant thrust than the Shkadov thruster, making it a more powerful and efficient method for moving stars. Stellar engines could enable humanity to explore and colonize new regions of the galaxy. By moving our solar system closer to other stars, we could make interstellar travel more feasible, reducing the distances between solar systems and opening up new opportunities for exploration and settlement. This could lead to the establishment of human colonies on exoplanets or in other star systems, spreading life across the galaxy and creating a network of interconnected civilizations. Stellar engines could also play a role in the long-term management of the galaxy's resources. As humanity expands and consumes more energy, access to new sources of energy will become increasingly important. By moving our solar system to regions of the galaxy rich in resources, such as areas with high concentrations of dark matter or other valuable materials, we could ensure a steady supply of energy and resources for future generations. This would enable the continued growth and development of human civilization on a galactic scale. Number 13. Space-based particle accelerators. Space-based particle accelerators represent an extraordinary leap in scientific ambition, taking the concept of particle physics research to new cosmic heights. These colossal machines would be designed to accelerate subatomic particles to nearly the speed of light, enabling experiments that could probe the deepest mysteries of the universe. By constructing these accelerators in the vacuum of space, far beyond the limitations of Earth-bound facilities, scientists could achieve energies and conditions unattainable on our planet, leading to groundbreaking discoveries that could reshape our understanding of physics and the cosmos. A space-based particle accelerator would operate on the same basic principles as those on Earth, such as the Large Hadron Collider at CERN, but on an incomparably larger scale. Particles, such as protons or electrons, would be injected into the accelerator and guided along a circular or linear path by powerful magnetic fields. As the particles travel through the accelerator, they would be subjected to electromagnetic fields that accelerate them to incredible speeds, approaching the speed of light. These high-energy particles would then be collided with each other or with stationary targets, allowing scientists to observe the resulting interactions and study the fundamental forces in particles that make up the universe. Building a space-based particle accelerator offers several distinct advantages over Earth-based facilities. The most significant is the absence of atmospheric and gravitational constraints. In the vacuum of space, particles can be accelerated over much longer distances without losing energy to air resistance or being affected by Earth's gravity. This allows for the construction of much larger accelerators, potentially spanning hundreds or even thousands of kilometers. The larger the accelerator, the higher the energy levels that can be achieved, enabling the study of phenomena that require extreme conditions, such as those present in the early moments of the universe. Another advantage of constructing particle accelerators in space is the reduced risk of radiation exposure to humans and the environment. High-energy particle collisions can produce intense radiation, including harmful gamma rays and other forms of ionizing radiation. By placing these accelerators in space, far from Earth, the potential dangers associated with these experiments would be minimized, allowing scientists to conduct more powerful and ambitious experiments without risking public safety. One of the most profound benefits of a space-based particle accelerator would be its potential to answer fundamental questions about the nature of the universe. For instance, these accelerators could recreate conditions similar to those just after the Big Bang, allowing scientists to study the formation of matter, the behavior of dark matter, and the unification of fundamental forces. By achieving higher energies than those possible on Earth, these accelerators could explore new realms of physics, potentially leading to the discovery of unknown particles or forces, and deepening our understanding of the fabric of reality. In addition to advancing our knowledge of fundamental physics, space-based particle accelerators could have practical applications that benefit humanity. For example, they could be used to test and develop new materials and technologies that can withstand extreme conditions, such as those encountered in space exploration or nuclear fusion reactors. These advancements could lead to more durable spacecraft, improved energy production methods, and new industrial processes that enhance sustainability and efficiency. In the future, a network of space-based particle accelerators could be established across the solar system, providing a platform for continuous and collaborative research on an unprecedented scale. Such a network could bring together scientists from around the world, fostering international cooperation and shared knowledge. The data generated by these accelerators could revolutionize our understanding of the universe, leading to new theories and discoveries that could reshape the course of human history. Number 14. Universal constructors. Universal constructors in space represent one of the most ambitious concepts in the field of space exploration and megastructure construction. These theoretical machines, sometimes referred to as von Neumann machines, after the mathematician who first conceived the idea, are designed to be fully autonomous, self-replicating robots capable of building virtually anything, including themselves. Operating in space, these universal constructors could revolutionize humanity's ability to construct large-scale structures and harness resources from other planets, asteroids, and beyond. A universal constructor would work by first using raw materials available in space, such as the minerals found in asteroids, moons, or even planetary surfaces, to create components and machinery. These materials would be mined, refined, and processed by the constructor itself, which would then use them to fabricate new units or to assemble complex structures. One of the most critical aspects of these machines is their ability to replicate themselves, meaning that a single universal constructor could build copies of itself, exponentially increasing the number of constructors working in space. This self-replication process could turn a small initial investment into a vast fleet of machines capable of undertaking massive construction projects across the solar system. The potential benefits of universal constructors for humanity are immense. One of the most significant advantages would be their ability to construct large-scale space infrastructure without the need for constant resupply from Earth. This could include building space habitats, solar power stations, or even planetary defense systems. By using local resources and being fully autonomous, universal constructors would reduce the need for costly and risky launches from Earth, making space exploration and development more sustainable and affordable. Another profound benefit of universal constructors would be their role in asteroid mining. The vast resources locked within asteroids, such as rare metals and water, could be harnessed by these machines to support both Earth's economy and future space colonization efforts. The extracted materials could be used to build space habitats, fuel stations, or other essential infrastructure, potentially leading to a self-sufficient space economy. Moreover, by mining asteroids and other celestial bodies, humanity could reduce the environmental impact of mining on Earth, preserving our planet's ecosystems while still meeting the growing demand for resources. Universal constructors could also play a crucial role in the construction of space megastructures, such as Dyson spheres or O'Neill cylinders. These colossal structures, designed to harness massive amounts of energy or provide living space for millions of people, would require the assembly of materials on an unprecedented scale. Universal constructors, with their ability to replicate and work autonomously, would be the perfect solution to the logistical challenges of building such megastructures. They could operate in the vacuum of space, assembling components piece by piece over long periods, eventually creating structures that would be impossible to build using traditional methods. In the future, as technology advances, universal constructors could even be used to terraform planets or moons, making them suitable for human habitation. By constructing vast networks of infrastructure and altering the environment of these celestial bodies, these machines could lay the groundwork for new human colonies, extending humanity's reach into the cosmos. This capability would be essential for long-term survival and expansion, allowing humans to establish a presence on multiple planets and reduce the risk of extinction from global catastrophes on Earth. Moreover, the development and deployment of universal constructors could lead to a new era of exploration and discovery. With a fleet of self-replicating machines, humanity could explore the farthest reaches of the solar system and beyond, building research stations, telescopes, and communication networks to study the universe in greater detail. Number 15. Dyson spheres. Dyson spheres are one of the most ambitious and iconic concepts in the realm of space megastructures, representing a theoretical structure designed to harness the total energy output of a star. Named after the physicist Freeman Dyson, who popularized the idea in the 1960s, a Dyson sphere would be an enormous shell surrounding a star, capturing and converting its radiant energy into usable power. The idea stems from the notion that as a civilization grows and its energy needs increase, it would eventually seek to capture the full energy potential of its star, propelling it to a new level of technological advancement. Since Dyson spheres are quite similar to Dyson swarms, which were discussed earlier, I won't go into detail about their energy benefits. One of the most compelling aspects of a Dyson sphere is its potential to serve as a habitat for an enormous population. The sheer scale of the structure means that it could provide living space for trillions of people, far exceeding the capacity of Earth. Each habitat within the Dyson swarm could be designed with artificial gravity, climate control, and ecosystems tailored to human needs, offering a comfortable and Earth-like environment in space. These habitats could be connected through a network of transportation systems, communication links, and energy grids, creating a cohesive and interconnected civilization spread across millions of individual units. Given the potential material limitations within our solar system, constructing a Dyson sphere might be more feasible in another solar system in the distant future. Additionally, if alien civilizations have constructed Dyson spheres, these structures could serve as markers to identify and locate those civilizations. Number 16. Starlifters. Starlifters are an advanced and speculative concept in the field of space megastructures, representing one of the most ambitious ideas for harnessing the vast energy and material resources of stars. The idea behind a starlifter is to construct a massive structure or system capable of extracting matter directly from a star, such as our Sun, to utilize its elements for various purposes. This process could enable humanity to access enormous quantities of raw materials, potentially transforming our ability to build large-scale space structures and sustain long-term space exploration. A starlifter would work by creating a mechanism that could reach into the outer layers of a star and extract its material without disrupting the star's stability. This could be achieved using advanced technologies like powerful magnetic fields, solar sails, or even a series of interconnected tethers designed to pull stellar material away from the star's surface. Once extracted, the matter could be processed and separated into its constituent elements, such as hydrogen, helium, and heavier metals, which could then be used for various applications. One of the primary uses of the material harvested by a starlifter would be in the construction of other space megastructures, such as Dyson spheres, space habitats, or even more starlifters. Stars contain vast amounts of hydrogen, which could be used as fuel for fusion reactors, providing a nearly limitless energy supply for human civilization. The ability to extract and utilize these elements would vastly expand our resource base, reducing our dependence on the limited resources available on Earth and within our solar system's asteroids and planets. Beyond resource extraction, starlifters could also play a crucial role in managing the long-term future of stars. As stars age, they go through various stages of evolution, eventually exhausting their nuclear fuel and potentially undergoing catastrophic changes, such as expanding into red giants or collapsing into supernovae. For example, starlifters could be employed to extend the lifespan of our Sun, delaying its predicted expansion into a red giant about 5 billion years from now. This would enable Earth to support life for much longer than current scientific predictions suggest. Number 17. Stanford Torus. The Stanford Torus is a concept for a space habitat that could provide a permanent living environment for humans in space. Originally proposed in the 1970s by a team of researchers at Stanford University as part of a NASA study, the Stanford Torus is a giant, donut-shaped structure designed to orbit Earth or another celestial body. This space megastructure would rotate to create artificial gravity, allowing humans to live and work in a comfortable, Earth-like environment while orbiting in space. This space megastructure is also featured in the movie Elysium, where it serves as a luxurious haven for the wealthy. The Stanford Torus would work by rotating around its central axis, with the rotational speed carefully calculated to create centrifugal force equivalent to Earth's gravity. This force would push everything inside the torus outward, mimicking the experience of gravity and enabling people to walk, move, and build as they would on Earth. The Stanford Torus would be notably smaller than an O'Neill cylinder and have a diameter of about 1 mile. It would rotate at approximately 1 revolution per minute to generate the desired level of gravity. The interior of the torus would be lined with habitats, parks, agricultural zones, and other facilities necessary for sustaining human life. Since the Stanford Torus is quite similar to O'Neill cylinders, I won't delve further into its interior and overall structure. For more details about those aspects, please refer to the section on O'Neill cylinders. The Stanford Torus could play a key role in the colonization of other celestial bodies, such as the Moon or Mars. By providing a nearby base of operations, the Torus could support missions to the surface of these bodies, serving as a staging ground for exploration, resource extraction, and eventual settlement. The Torus itself could be expanded or replicated, creating a network of interconnected habitats that support a growing human presence in space. In the future, the Stanford Torus could also serve as a hub for space tourism, providing a unique destination for visitors seeking to experience life in space. As space travel becomes more accessible, the Torus could offer a comfortable and safe environment for tourists, allowing them to enjoy the beauty of space while participating in activities such as zero-gravity sports, stargazing, and virtual reality experiences. This could open up new avenues for economic growth and help to democratize access to space, making it a more integral part of human life. Number 18. Alderson disks. Alderson disks are one of the most ambitious and speculative concepts in the realm of space megastructures, offering an entirely new vision of how humanity could inhabit and utilize space. Named after the science fiction author Dan Alderson, who first proposed the idea, an Alderson disk would be a massive flat structure surrounding a star, providing a habitable surface area that could dwarf that of any planet. An Alderson disk would be considerably larger than a ringworld. An Alderson disk would be so large that its radius could extend from the orbit of Mercury to beyond the orbit of Mars, creating an immense, continuous landmass with the potential to support trillions of people. The fundamental idea behind an Alderson disk is to create a habitable environment by constructing a colossal disc-shaped platform around a star. The star would sit at the center of the disk, providing energy and light to the vast surface area of the structure. The disk itself would need to be incredibly thick to generate enough gravitational pull to keep its atmosphere and inhabitants securely in place. This gravity would be similar to that on Earth, allowing for normal living conditions. The outer edge of the disk could be several astronomical units away from the star, making the habitable zone of the disk incredibly vast. One of the most interesting aspects of an Alderson disk is the potential for controlled climates and ecosystems. Given the sheer size of the disk, it could be designed with different regions having varied climates, from tropical zones near the star to temperate regions farther out. Artificial oceans, rivers, and mountains could be constructed across the disk, creating a diverse range of environments for agriculture, habitation, and natural ecosystems. The disk's immense surface area would offer virtually unlimited space for cities, farmlands, and nature reserves, allowing humanity to expand and thrive without the environmental constraints we face on Earth. In terms of energy, an Alderson disk would have almost limitless potential. Solar energy collectors could be spread across the disk's surface to harness the star's power, providing an inexhaustible energy supply for the inhabitants. This energy could be used not only for daily needs, but also for large-scale industrial processes, space travel, and other advanced technologies. With such abundant energy resources, the disk could become a hub for scientific research, manufacturing, and technological innovation, driving human progress to new heights. Another significant benefit of an Alderson disk is its potential to serve as a stable platform for deep space exploration. With such a large and resource-rich structure, the disk could support the construction and launch of interstellar spacecraft, providing a base for humanity's expansion into the wider galaxy. The disk's proximity to its star also means that it could be an ideal location for observing and studying the star itself, as well as for monitoring and managing space traffic in the surrounding system. Additionally, the disk could act as a shield, protecting its inhabitants from space debris and cosmic radiation, thanks to its thick, robust construction. Number 19. Planetary engines. Planetary engines are an extraordinary concept within the realm of space megastructures, offering a theoretical means of moving entire planets. The idea behind planetary engines is to build colossal machines that can generate enough thrust to alter a planet's orbit, direction, or even its position within the solar system. For information on potential designs for planetary engines, please refer to the earlier section on stellar engines. The potential benefits of planetary engines for humanity are profound, particularly when considering the long-term survival and adaptability of our civilization. One of the most significant advantages would be the ability to protect Earth or other inhabited planets from cosmic threats. For instance, in the distant future, the Sun is predicted to eventually exhaust its nuclear fuel and expand into a red giant, potentially engulfing the inner planets, including Earth. By using a planetary engine, humanity could slowly move Earth away from the expanding Sun, preserving the planet's habitability and ensuring the survival of life. Planetary engines could also be used to prevent catastrophic asteroid or comet impacts. If a large enough object were detected on a collision course with Earth, a planetary engine could be activated to gently alter Earth's orbit, moving it out of the path of the incoming object. This would provide a powerful tool for planetary defense, reducing the risk of extinction-level events. Moreover, planetary engines could play a role in terraforming and climate control. If a planet's orbit or axial tilt is adjusted, it could change the distribution of sunlight and heat across the planet's surface, potentially stabilizing its climate or making it more suitable for life. For example, a planetary engine could be used to slightly alter Earth's tilt or orbit, helping to mitigate the effects of climate change or to make other planets such as Mars more habitable. And we could potentially move planets like Mars and Venus to more habitable regions of the solar system. However, altering planetary locations carries significant risks, and the effects of changing the gravitational balance in the solar system would need to be carefully evaluated. Number 20. Atmosphere harvesters. Atmosphere harvesters are an innovative concept that could play a crucial role in humanity's future exploration and colonization of other planets. These megastructures would be designed to extract and process gases from the atmospheres of planets, moons, or even gas giants, converting them into usable resources such as oxygen, water, and fuel. By harnessing the abundant atmospheric resources found on other celestial bodies, atmosphere harvesters could support sustained human presence in space, reduce the need for resupply missions from Earth, and open up new possibilities for space exploration and industry. An atmosphere harvester would work by first capturing atmospheric gases using large-scale intake systems, which might resemble massive scoops or funnels. These structures would be positioned in or above the atmosphere of a target planet or moon, where they could continuously collect gases as they move through the atmosphere. Once the gases are captured, they would be directed into processing units within the harvester. Here, the gases would be separated, purified, and converted into useful forms. For example, carbon dioxide could be split into oxygen and carbon, while hydrogen could be extracted from water vapor. The resulting products could then be stored for later use or transported to other locations. One of the most promising applications of atmosphere harvesters is on Mars, where the atmosphere is composed primarily of carbon dioxide. An atmosphere harvester on Mars could produce oxygen for human consumption and rocket fuel for return missions or travel to other destinations. This capability would be a game changer for Mars exploration and colonization, as it would significantly reduce the reliance on supplies sent from Earth. Instead, astronauts could produce much of what they need directly from the Martian environment, making long-term missions more sustainable and cost-effective. In addition to supporting human life, atmosphere harvesters could be used to produce water, which is essential for both drinking and agriculture. By extracting water vapor from the atmosphere or processing hydrogen and oxygen, these structures could create a reliable water supply for space colonies. This would enable the cultivation of crops and the development of self-sustaining ecosystems on other planets, further reducing the need for Earth-based resources and increasing the viability of space colonization. Another potential application of atmosphere harvesters is on gas giants like Jupiter or Saturn. These planets have thick atmospheres rich in hydrogen and helium, which could be harvested and used as fuel for fusion reactors or advanced propulsion systems. By tapping into these vast atmospheric reserves, humanity could gain access to nearly limitless energy resources, driving technological advancements and enabling more ambitious space missions. The ability to harvest fuel directly from the atmospheres of gas giants could also make deep space exploration more feasible, allowing spacecraft to refuel as they travel through the solar system. Atmosphere harvesters could also contribute to terraforming efforts, where the goal is to alter the environment of a planet or moon to make it more habitable for humans. By selectively extracting or adding specific gases to an atmosphere, these structures could help regulate temperature, pressure, and composition, gradually transforming the environment to better support life. For instance, on Mars, atmosphere harvesters could be used to increase the level of greenhouse gases, warming the planet and thickening its atmosphere, which could eventually make it more Earth-like. These harvesters would likely be highly automated as well, using advanced AI and robotics to manage the complex processes of gas extraction and conversion. The technologies developed for atmosphere harvesters could have applications on Earth as well, such as in environmental monitoring, air purification, and industrial gas production. 15 robotics technologies are changing our world forever, but not in ways you might expect. For example, humanoid robots. Humanoid robots have made incredible strides in recent years, with advancements that could revolutionize daily life and industries alike. Designed to replicate human form and functions, these robots have seen notable improvements in mobility, dexterity, and interaction capabilities, making them increasingly versatile and practical. As these cutting-edge developments continue, humanoid robots are poised to bring transformative changes across a wide range of fields. Companies like Tesla and Figure are pioneering rapid advancements in humanoid robotics. Tesla's Optimus robot is designed to handle repetitive or dangerous tasks in manufacturing and beyond, leveraging Tesla's breakthroughs in AI and autonomous systems. Figure, a newer player, is building highly advanced humanoid robots that can autonomously perform human-level tasks. Their Figure 01 robot has garnered attention for its ability to learn from human actions through AI models, marking a significant leap in the field. Both Tesla and Figure aim to revolutionize industries by deploying these robots in various roles, from manufacturing and healthcare to household assistance. Human-robot interaction has seen significant advancements, with robots like Mecha and Hanson Robotics' Sophia leading the way. Mecha, developed by Engineered Arts, is equipped with some of the most advanced AI and natural language processing systems available, allowing it to understand human speech, recognize emotions, and even display realistic facial expressions. This makes Mecha particularly adept at engaging in meaningful conversations with humans. Sophia, known for her lifelike appearance and conversational abilities, has also been a key figure in this field. The development of such humanoid robots brings us closer to integrating robots into everyday life, enhancing their utility across sectors such as customer service, education, and healthcare. Another intriguing advancement in humanoid robots is their enhanced mobility and balance. Robots like Boston Dynamics Atlas have demonstrated exceptional agility, capable of walking on uneven terrain, jumping, and even performing gymnastic routines. These capabilities are achieved through advanced sensors, actuators, and real-time processing of vast amounts of data, allowing the robots to adapt their movements dynamically. This progress paves the way for robots to assist in disaster response, search and rescue missions, and other scenarios where human-like mobility is crucial. Looking into the future, humanoid robots equipped with general intelligence and reasoning capabilities will revolutionize numerous aspects of daily life and industry. These robots will not only be able to perform complex tasks autonomously, but will also learn from their experiences, improving their efficiency and adaptability over time. With the ability to make decisions and solve problems, these humanoid robots will no longer require constant human supervision, making them invaluable assets in a wide range of environments. Their versatility will allow them to transition seamlessly between tasks, whether it be assisting in hospitals, classrooms, or factories. In healthcare, humanoid robots will transform patient care. They will be able to monitor vital signs, assist in medical procedures, and provide companionship to the elderly and disabled, alleviating the strain on healthcare workers and improving patient outcomes. These robots could serve as personal aides, ensuring that those with limited mobility receive the support they need, from daily tasks to complex medical monitoring. In educational settings, humanoid robots will function as interactive teaching tools, offering personalized learning experiences to students and supporting those with special needs, making education more inclusive and tailored. The industrial and manufacturing sectors will see substantial benefits from these advanced robots. In factories, humanoid robots will collaborate closely with human workers, handling dangerous or repetitive tasks, while allowing humans to focus on creative and strategic work. This form of collaboration, or cobotics, will lead to safer, more productive work environments. The robots' enhanced physical abilities, including strength and agility, will also make them invaluable in construction and logistics, where they can perform physically demanding tasks with precision. While the potential of humanoid robots is vast, their integration into society raises important ethical concerns. The possibility of job displacement, questions surrounding privacy, and the evolving dynamics of human-robot relationships must be carefully considered. To ensure that the benefits of these robots are shared equitably, it will be essential to develop ethical guidelines and regulatory frameworks that address these issues, fostering a future where humans and robots coexist harmoniously. Make sure to stick around to the end because this video explores space robots, military robots, autonomous vehicles, robotic pets, exoskeletons, and more. Number 2. Nanobots. Nanobots represent one of the most exciting frontiers in robotics, offering the potential to revolutionize medicine, environmental management, and various industrial processes. These microscopic robots, often only a few nanometers in size, are designed to perform specific tasks at a molecular or cellular level with unprecedented precision. One of the most promising advancements in nanobots is their application in medicine, particularly for targeted drug delivery. Researchers are developing nanobots that can navigate through the human body to deliver drugs directly to diseased cells, such as cancerous tumors, without affecting healthy tissue. This targeted approach enhances the efficacy of treatments while minimizing side effects. For example, scientists have created nanobots coated with specific molecules that bind to cancer cells, releasing chemotherapy drugs precisely where they are needed. This precision targeting could significantly improve cancer treatment outcomes and reduce the harsh side effects associated with traditional chemotherapy. Another fascinating development is the use of nanobots for minimally invasive surgery. These tiny robots can be injected into the body and controlled to perform delicate surgical procedures that would be impossible with conventional tools. For instance, nanobots could be used to clear blockages in blood vessels, repair damaged tissues, or remove plaque from arteries. This approach reduces the need for large incisions in major surgeries, leading to faster recovery times and fewer complications for patients. Nanobots are also being explored for their potential in diagnostic applications. Equipped with advanced sensors, nanobots can travel through the bloodstream to detect biomarkers associated with diseases such as diabetes, cardiovascular conditions, and infections. These nanobots can transmit real-time data to healthcare providers, enabling early diagnosis and timely intervention. The ability to monitor health conditions continuously and non-invasively could transform preventive medicine and improve patient outcomes. In the environmental sector, nanobots are being developed to address pollution and clean up contaminated environments. For example, researchers are designing nanobots that can break down harmful chemicals and pollutants in water, soil, and air. These nanobots can operate at the molecular level to neutralize toxins and restore ecosystems. Additionally, nanobots could be used to monitor environmental conditions and provide real-time data on pollution levels, helping to inform and implement more effective environmental protection measures. Looking into the future, nanobots are expected to become even more advanced and versatile. One area of potential growth is the development of self-replicating nanobots, which can create copies of themselves using materials found in their environment. These self-replicating nanobots could be deployed in large numbers to perform extensive tasks, such as repairing infrastructure, cleaning up oil spills, or constructing complex structures at the nanoscale. This capability would significantly expand the applications and scalability of nanobot technology. Advancements in AI and machine learning will further enhance the capabilities of nanobots. AI-powered nanobots could analyze their surroundings, make autonomous decisions, and adapt to changing conditions in real time. This intelligence would enable nanobots to perform more complex and dynamic tasks, such as navigating through the human body to diagnose and treat multiple health conditions simultaneously. The integration of AI will also improve the efficiency and accuracy of nanobots, making them more reliable and effective in their applications. The miniaturization and integration of advanced materials will continue to drive innovation in nanobot design. Researchers are exploring the use of materials such as graphene and carbon nanotubes to enhance the strength, flexibility, and functionality of nanobots. These materials can improve the durability and performance of nanobots, enabling them to operate in harsh environments and perform intricate tasks with greater precision. The development of biocompatible materials will also ensure that nanobots can safely interact with biological systems without causing adverse reactions. Moreover, the potential for nanobots to revolutionize various industries extends beyond healthcare and environmental management. In manufacturing, nanobots could be used to assemble products at the molecular level, leading to the creation of new materials and devices with unprecedented precision and efficiency. In agriculture, nanobots could monitor soil health, detect pests, and deliver nutrients directly to plants, improving crop yields and reducing the need for chemical fertilizers and pesticides. Number 3. Space robots. Space robots are transforming our ability to explore and operate in the final frontier, offering new possibilities for scientific discovery, space exploration, and commercial activities. These robots, designed to operate in the harsh and unpredictable environment of space, are equipped with advanced technologies that enable them to perform tasks that are too dangerous or complex for humans. One of the most exciting advancements in space robotics is the development of robotic arms and manipulators used on spacecraft and space stations. The Canadarm2, a robotic arm on the International Space Station, also known as ISS, is a prime example. It has been instrumental in assembling the ISS, capturing cargo spacecraft, and assisting astronauts during spacewalks. These robotic arms are controlled remotely by astronauts or ground operators, and their precision and dexterity allow them to perform delicate tasks, such as repairing equipment and conducting scientific experiments. The success of the Canadarm2 has paved the way for more advanced robotic systems, such as the European robotic arm and Japan's Kibo robotic arm, which further enhance the operational capabilities of space missions. Another significant advancement is the development of autonomous rovers, such as NASA's Perseverance rover on Mars. Equipped with advanced navigation systems, cameras, and scientific instruments, Perseverance is exploring the Martian surface, searching for signs of past life and collecting samples for future return to Earth. The rover's autonomy allows it to navigate challenging terrains, avoid obstacles, and make real-time decisions without direct human intervention. This capability is crucial for exploring distant planets and moons, where communication delays make real-time control impractical. The data collected by these rovers provide valuable insights into the geology, climate, and potential habitability of other celestial bodies. In addition to rovers, space robots are also being developed for in-orbit servicing and maintenance. The Restore-L mission by NASA aims to demonstrate the ability to refuel, repair, and upgrade satellites in orbit, extending their operational lifetimes and reducing space debris. These servicing robots use advanced robotic arms, cameras, and tools to perform precise tasks on satellites, all while operating autonomously or under remote control. The success of such missions could revolutionize satellite operations, making space activities more sustainable and cost-effective. Looking into the future, space robotics is expected to become even more advanced and versatile. One area of potential growth is the development of robotic explorers for missions to the outer planets and their moons. For instance, robots designed to operate in the icy environments of Europa or Enceladus could drill through ice layers to search for signs of life in subsurface oceans. These robots would need to withstand extreme temperatures and radiation, and their autonomous capabilities would be crucial for navigating and conducting scientific research in these distant and challenging environments. The advancement of AI and machine learning will further enhance the capabilities of space robots. Future robots could analyze vast amounts of data in real time, adapt to changing conditions, and learn from their experiences. This would enable them to perform more complex tasks with greater autonomy, such as constructing habitats on the Moon or Mars, mining asteroids for resources, and establishing infrastructure for human colonization. AI-powered robots could also collaborate with human astronauts, providing assistance during spacewalks, conducting scientific experiments, and managing routine maintenance tasks, thus freeing up astronauts to focus on more critical mission objectives. The integration of modular and reconfigurable robotic systems is another promising development. These robots can be assembled and reconfigured in space to suit different tasks and missions. For example, modular robots could be used to construct large structures, such as space telescopes, habitats, or solar power arrays, directly in space. This approach would reduce the need for large, single-purpose spacecraft and allow for more flexible and scalable space operations. The potential for swarm robotics in space exploration is also gaining interest. Swarms of small, interconnected robots could work together to perform tasks such as mapping the surfaces of planets and moons, conducting geological surveys, and exploring lava tubes and caves. These robotic swarms could cover large areas more efficiently than a single rover, providing more comprehensive data and increasing the chances of discovering valuable resources or scientific phenomena. Creating professional quality videos can be challenging, but imagine generating one instantly with just a text prompt. That's exactly what InVideo offers. InVideo allows you to create publish-ready videos without any video editing experience. Simply type in your topic, and InVideo's AI takes care of everything, from generating the script and visuals to adding voiceovers, subtitles, and music. For example, here's a video about humanoid robots that was generated in less than 2 minutes. Trusted by over 25 million users globally, InVideo is a game changer for creators looking to speed up their content production. The platform's AI even lets you make real-time edits with text prompts, clone your voice, and translate videos into over 50 languages. Notice how easily you can change the footage in this section of a video it generated. It's an all-in-one solution that transforms any idea into a polished video in minutes. Future business tech viewers can try InVideo for free. Just visit invideo.io/futurebusinesstech or click the link in the description. Use this code to double your video generation credits during your first month. With InVideo, your creative process is faster and simpler than ever. Now let's jump back into our journey into the future of technology. Number 4. Military robots. Military robots are rapidly transforming modern warfare and defense strategies, offering advanced solutions for reconnaissance, combat, logistics, and search and rescue missions. These robots are designed to operate in challenging and dangerous environments, reducing the risk to human soldiers and enhancing operational effectiveness. One of the most significant advancements in military robotics is the development of autonomous ground vehicles. Robots like the multi-purpose unmanned tactical transport by General Dynamics and the tracked hybrid modular infantry system by Milrem Robotics are designed to support ground troops by carrying heavy equipment, providing cover, and even engaging in combat. These unmanned ground vehicles are equipped with advanced navigation systems, sensors, and AI algorithms that enable them to navigate complex terrains, avoid obstacles, and make autonomous decisions. By taking on dangerous and labor-intensive tasks, these robots allow human soldiers to focus on strategic operations and reduce their exposure to harm. Drones, or unmanned aerial vehicles, represent another critical advancement in military robotics. Drones like the MQ-9 Reaper and the RQ-4 Global Hawk are used for surveillance, reconnaissance, and targeted strikes. Equipped with high-resolution cameras, thermal imaging, and radar, these drones can gather real-time intelligence, monitor enemy movements, and provide aerial support to ground troops. Their ability to operate at high altitudes and over long distances makes them invaluable for missions that require persistent surveillance and rapid response. The integration of AI and machine learning further enhances their capabilities, allowing drones to autonomously identify targets, track multiple objects, and adapt to changing conditions. In the evolving landscape of military robotics, robot dogs equipped with firearms have emerged as a significant innovation. For instance, Ghost Robotics has developed a quadrupedal robot which can carry and fire a long-range rifle. This robot dog is remotely controlled by human operators using an Android tablet and is designed to perform tasks in environments too dangerous or inaccessible for human soldiers. Additionally, these robotic dogs have potential for autonomous target acquisition and firing, though human control remains a critical safety feature. Another exciting development is the use of underwater drones, or unmanned underwater vehicles, for naval operations. Unmanned underwater vehicles like the Remus and the Sea Fox are designed for mine detection, reconnaissance, and anti-submarine warfare. These underwater robots are equipped with sonar, cameras, and advanced navigation systems that enable them to operate autonomously in challenging marine environments. By conducting underwater missions, these vehicles enhance the Navy's ability to secure maritime routes, detect threats, and gather intelligence without putting human divers at risk. In the future, military robots will become a significant force in modern warfare, featuring advancements that enhance both their durability and effectiveness on the battlefield. Robot soldiers, equipped with armor capable of withstanding .50 caliber rounds, will be nearly indestructible in combat, offering military units a resilient, tireless front line. These robots will have the ability to assess tactical situations in real time, making split-second decisions that reduce risks for human soldiers. Unlike their human counterparts, robot soldiers will not require rest, making them an unrelenting force in prolonged engagements. Complementing these robot soldiers will be advanced robotic dogs armed with guns and equipped with night vision capabilities. These relentless machines will be able to navigate through rough terrains and urban environments with ease, acting as both offensive units and scouts. Capable of autonomous decision-making, these robot dogs will be valuable assets in high-risk missions, providing crucial intelligence and firepower while keeping human forces at a safe distance. Additionally, the rise of autonomous jets and weaponized miniature drones will redefine air combat. Autonomous jets powered by advanced AI will be able to execute complex aerial maneuvers and engage in dogfights with unparalleled precision. These jets will operate without the need for pilots, significantly reducing human casualties in the air. Meanwhile, miniature weaponized drones will serve as lethal, agile units capable of infiltrating enemy defenses undetected. Whether deployed for targeted strikes or reconnaissance, these drones will offer new strategies for military forces, transforming how wars are fought and making the battlefield more reliant on robotic systems than ever before. Number 5. Bionic robotics. Bionic robotics is at the cutting edge of technology, merging biological principles with advanced engineering to create robotic systems that enhance or replicate human capabilities. These innovations are transforming fields such as medicine, rehabilitation, and human augmentation, offering new possibilities for improving quality of life and expanding human potential. One of the most remarkable advancements in bionic robotics is the development of advanced prosthetics. Modern bionic limbs, such as those created by companies like Osur and Deca Research, are equipped with sensors and actuators that mimic the natural movement of human limbs. These prosthetics use myoelectric sensors to detect electrical signals from the user's muscles, translating them into precise movements of the artificial limb. This technology allows users to perform a wide range of tasks with greater dexterity and control, significantly improving their independence and quality of life. For example, the Deca arm, also known as the Luke arm, named after the Star Wars character, allows users to perform complex tasks such as picking up small objects, using tools, and even shaking hands. Bionic robotics is also making strides in sensory augmentation, particularly in the development of bionic eyes and ears. Bionic eyes, such as the Argus 2 retinal prosthesis system, are designed to restore partial vision to individuals with certain types of blindness. These systems use a combination of cameras, processors, and electrode arrays to stimulate the remaining healthy cells in the retina, allowing users to perceive light and shapes. Similarly, bionic ears provide hearing to individuals with severe hearing loss by directly stimulating the auditory nerve. These sensory augmentation devices offer transformative benefits, enabling users to regain critical senses and interact more fully with their environment. Looking into the future, bionic robotics is expected to become even more advanced and integrated into everyday life. One area of potential growth is the development of brain-computer interfaces that connect bionic devices directly to the brain. Brain-computer interfaces could allow users to control bionic limbs, exoskeletons, or sensory devices with their thoughts, providing even greater precision and responsiveness. Researchers are already exploring the use of brain-computer interfaces for controlling prosthetic limbs and enabling communication for individuals with severe disabilities. This technology could lead to a new era of human-robot integration, where bionic devices function as natural extensions of the body. Advancements in material science will also play a crucial role in the evolution of bionic robotics. The development of lightweight, flexible, and biocompatible materials will make bionic devices more comfortable, durable, and effective. For instance, researchers are working on developing synthetic muscles made from advanced polymers that can mimic the properties of natural muscle tissue. These synthetic muscles could be used in prosthetics and exoskeletons to provide more natural and powerful movements, enhancing the overall performance of bionic devices. The integration of artificial intelligence and machine learning will further enhance the capabilities of bionic robotics. AI algorithms can analyze data from sensors and user inputs to optimize the performance of bionic devices, adapting to the user's needs and preferences in real time. For example, AI-powered prosthetics could learn the user's walking pattern and adjust the movement of the artificial limb to provide smoother and more efficient gait. Similarly, AI could be used to enhance the functionality of sensory augmentation devices, improving the quality of vision or hearing provided by bionic eyes and ears. Moreover, the affordability and accessibility of bionic robotics are expected to improve as technology advances and production costs decrease. This democratization of bionic technology will make advanced prosthetics, exoskeletons, and sensory devices available to a wider range of individuals, including those in low-resource settings. Enhanced access to bionic robotics will enable more people to benefit from these life-changing technologies, promoting greater inclusivity and equality. Number 6. Underwater exploration robots. Underwater exploration robots are at the forefront of technological advancements, offering unprecedented opportunities to explore and understand the vast, uncharted regions of our oceans. These robots, designed to operate in extreme underwater environments, are equipped with cutting-edge technology that allows them to perform tasks ranging from scientific research to industrial inspections. One of the most exciting developments in underwater robotics is the advancement of autonomous underwater vehicles. These robots, such as the Remus series by Hydroid and the Bluefin robotics vehicles, are designed to operate independently, navigating through complex underwater terrains using sophisticated navigation systems and sensors. These vehicles are capable of mapping the ocean floor, collecting data on water quality, and capturing high-resolution images of marine habitats. Equipped with advanced sonar and imaging technologies, these robots can provide detailed, three-dimensional maps of underwater environments, helping scientists uncover the mysteries of the deep sea. Remotely operated vehicles represent another significant advancement in underwater exploration. These types of vehicles are tethered to a surface vessel and operated by a human controller. These robots are equipped with high-definition cameras, robotic arms, and a variety of sensors, enabling them to perform intricate tasks in deep-sea environments. For instance, Vehicles like the Hercules, used by the Ocean Exploration Trust, have been instrumental in discovering shipwrecks, studying hydrothermal vents, and investigating underwater ecosystems. The precise control and versatility of these vehicles make them invaluable tools for marine research and industrial applications, such as underwater construction and pipeline inspections. The integration of AI and machine learning into underwater robots is enhancing their capabilities even further. AI algorithms enable these robots to process vast amounts of data in real time, identify patterns, and make autonomous decisions. For example, AI-powered autonomous underwater vehicles can adapt their missions based on the data they collect, allowing them to focus on areas of interest or avoid obstacles without human intervention. This autonomy reduces the need for constant monitoring and increases the efficiency and effectiveness of underwater exploration missions. In the future, underwater exploration robots could be capable of venturing to unprecedented depths, allowing humanity to explore the farthest reaches of the ocean floor. Equipped with advanced sensors and AI, these robots could be able to withstand immense pressure and operate autonomously in the darkest, most remote areas of the ocean. They will closely study the seabed in the deepest trenches, unlocking mysteries about Earth's geology and ecosystems that have remained hidden for millennia. These advanced exploration robots will also enable the discovery of new, unknown life forms thriving in extreme environments. By collecting samples and capturing high-resolution footage, they could reveal new species, some of which might have unique biological properties with potential applications in medicine, biotechnology, or material science. This new era of ocean exploration would deepen our understanding of marine biodiversity and Earth's last truly uncharted frontier. Number 7. Robotic pets. Robotic pets are emerging as a fascinating intersection of technology and companionship, offering innovative solutions for people who want the benefits of pet ownership without the challenges associated with live animals. These robotic companions are designed to mimic the behaviors and interactions of real pets, providing comfort, entertainment, and emotional support. One of the most notable advancements in robotic pets is the development of highly interactive and responsive robots. Sony's Aibo, for instance, is a robotic dog equipped with advanced sensors, cameras, and AI algorithms that enable it to recognize faces, respond to voice commands, and exhibit lifelike behaviors. Aibo can learn from its environment and adapt its behavior based on interactions with its owner, creating a personalized and engaging experience. Its ability to express emotions through movements, sounds, and LED lights enhances the sense of companionship, making it a beloved addition to many households. Another significant advancement is in the realm of therapeutic robotic pets designed to provide emotional support and companionship to the elderly and individuals with special needs. Robots like Paro, a robotic seal, have been used in nursing homes and healthcare facilities to provide comfort and reduce stress. Paro responds to touch, light, sound, and temperature, creating soothing interactions that can help alleviate feelings of loneliness and anxiety. These therapeutic robots offer a safe and hygienic alternative to live animals, particularly in settings where allergies, mobility issues, or cognitive impairments might limit the feasibility of traditional pet ownership. Robotic pets are also becoming more sophisticated in their ability to mimic the physical and emotional nuances of real animals. Advances in robotics and AI have enabled these pets to exhibit behaviors such as purring, wagging tails, and even simulating breathing patterns. For example, the Joy for All companion pets by Ageless Innovation are designed to replicate the look and feel of real cats and dogs, providing tactile and auditory feedback that enhances the realism of the interaction. These lifelike features make robotic pets more appealing and comforting to their owners. Looking into the future, robotic pets are expected to become even more advanced and integrated into our daily lives. One area of potential growth is the development of more autonomous and intelligent robotic pets that can perform practical tasks. Future robotic pets could be equipped with capabilities such as fetching items, reminding owners to take medications, or even providing basic home security. These multifunctional robots would combine companionship with utility, offering additional benefits beyond emotional support. Advancements in AI and machine learning will further enhance the personalization and adaptability of robotic pets. AI-powered pets could analyze their owner's behaviors and preferences to tailor their interactions accordingly. For instance, a robotic pet might learn to recognize when its owner is feeling sad and respond with comforting behaviors or playful activities to lift their spirits. The ability to understand and respond to human emotions will make robotic pets more intuitive and supportive companions. The integration of augmented reality and virtual reality technologies could also transform the experience of owning a robotic pet. AR and VR could create immersive environments where owners can interact with their robotic pets in new and exciting ways. For example, an augmented reality application might project virtual toys or obstacles for the robotic pet to interact with, enhancing the play experience. Virtual reality environments could allow owners to experience adventures and activities with their robotic pets, creating a deeper sense of connection and engagement. Moreover, the miniaturization and cost reduction of robotic components will make robotic pets more accessible to a wider audience. Affordable and versatile robotic pets could become commonplace in homes, schools, and healthcare facilities, providing companionship and support to people of all ages and backgrounds. This democratization of robotic pet technology will enhance the quality of life for many individuals, particularly those who may be unable to care for live animals. Number 8. Security Patrol Robots. Security Patrol robots are revolutionizing the field of security by offering advanced solutions for surveillance, threat detection, and emergency response. These robots are equipped with state-of-the-art technologies that enable them to autonomously patrol areas, monitor activities, and respond to security incidents. One of the most notable advancements in security patrol robots is the development of autonomous navigation systems. Robots like the Knightscope K5 and Cobalt Robotics security robots use a combination of sensors, cameras, and LiDAR to navigate complex environments without human intervention. These robots can patrol predefined routes, avoid obstacles, and adapt to changes in their surroundings. Their ability to operate autonomously reduces the need for human security personnel to perform routine patrols, allowing them to focus on more critical tasks. Advanced sensing and monitoring capabilities are another significant advancement in security patrol robots. Equipped with high-definition cameras, thermal imaging, and environmental sensors, these robots can detect and analyze various types of data in real time. For example, the K5 robot can identify suspicious activities, recognize license plates, and detect changes in temperature or air quality that might indicate a fire or hazardous material spill. This real-time data collection and analysis enables security personnel to respond quickly to potential threats and emergencies. AI and machine learning integration further enhance the capabilities of security patrol robots. These technologies enable robots to learn from their environments, recognize patterns, and make autonomous decisions. For instance, AI-powered security robots can identify and track individuals based on their behavior, detect unauthorized access, and trigger alerts if they notice unusual activities. This level of intelligence allows security robots to proactively address security issues, providing a higher level of protection and reducing the likelihood of incidents. In addition to monitoring and detection, security patrol robots are also being developed to provide direct intervention in certain situations. Robots like the SMP Robotics S5.2 can be equipped with tools such as pepper spray or sound alarms to deter intruders or de-escalate conflicts. These intervention capabilities enhance the robot's effectiveness in maintaining security and protecting assets. Looking into the future, security patrol robots are expected to become even more advanced and versatile. Swarms of security robots could collaborate to monitor extensive facilities, share data in real time, and coordinate responses to incidents. This collective approach would provide comprehensive coverage and enhance the overall security of large or complex environments. Advancements in communication technologies will further enhance the capabilities of security patrol robots. Improved connectivity, such as 5G networks, will enable robots to transmit high-definition video and data instantaneously, providing security personnel with real-time situational awareness. This connectivity will also allow for seamless integration with other security systems, such as surveillance cameras, access control systems, and emergency response networks. Robust energy management and longer battery life will also be critical advancements for future security patrol robots. As battery technology improves, robots will be able to operate for extended periods without needing recharges, making them more reliable for continuous surveillance. Additionally, the development of autonomous recharging stations will enable robots to recharge themselves as needed, ensuring uninterrupted operation. The miniaturization and cost reduction of robotic components will make security patrol robots more accessible to a wider range of organizations, including small businesses, schools, and residential communities. Moreover, the integration of advanced analytics and predictive capabilities will enhance the effectiveness of security patrol robots. Future robots could analyze historical data, recognize trends, and predict potential security threats, allowing for proactive measures to be taken before incidents occur. This predictive approach to security will improve prevention strategies and reduce the likelihood of security breaches. Number 9. Autonomous vehicles. Autonomous vehicles are essentially advanced robots, leading the charge in technological innovation. They showcase remarkable advancements that have the potential to revolutionize transportation and completely redefine how we experience mobility. These vehicles, capable of navigating and operating without human intervention, rely on a combination of advanced sensors, artificial intelligence, and machine learning to interpret their surroundings and make real-time decisions. One of the most fascinating advancements in autonomous vehicles is the development of sophisticated sensor systems. These systems include LiDAR, radar, cameras, and ultrasonic sensors, which work together to create a comprehensive 360-degree view of the vehicle's environment. LiDAR provides precise distance measurements by emitting laser beams and measuring their reflection times, while radar excels at detecting objects' speed and movement. Cameras capture high-resolution images to identify road signs, traffic signals, and obstacles, and ultrasonic sensors assist with close-range detection. This multi-sensory approach ensures that autonomous vehicles can detect and respond to a wide range of dynamic conditions on the road. The integration of AI and machine learning is crucial for the operation of autonomous vehicles. AI algorithms process the data collected by sensors, enabling the vehicle to recognize patterns, predict the behavior of other road users, and make informed decisions. Machine learning models are trained on vast amounts of driving data, allowing the vehicle to improve its performance over time. For example, autonomous vehicles can learn to identify and avoid potential hazards, navigate complex urban environments, and adapt to changing traffic conditions. This continuous learning process is essential for achieving higher levels of autonomy and reliability. One of the most promising applications of autonomous vehicles is in the realm of ride-sharing and public transportation. Companies like Waymo, Cruise, and Tesla are developing self-driving cars and shuttles that can provide on-demand transportation services. These vehicles have the potential to reduce traffic congestion, lower transportation costs, and increase accessibility, particularly in urban areas. By optimizing routes and operating continuously, autonomous ride-sharing services can improve the efficiency of transportation networks and reduce the environmental impact of individual car ownership. In the logistics and delivery sector, autonomous vehicles are poised to revolutionize the way goods are transported. Self-driving trucks and delivery vans can operate around the clock, reducing the need for human drivers and increasing the speed and efficiency of deliveries. Companies like Nuro and Gotic are already testing autonomous delivery vehicles for last-mile logistics, ensuring that packages and groceries can be delivered quickly and reliably. This could lead to significant cost savings for businesses and consumers, as well as reduced traffic and emissions from delivery vehicles. Looking into the future, autonomous vehicles are expected to become even more capable and widely adopted. Advances in AI and sensor technology will enable these vehicles to handle increasingly complex driving scenarios, such as navigating through adverse weather conditions or responding to unexpected road events. The development of vehicle-to-everything communication will further enhance safety and efficiency by allowing autonomous vehicles to communicate with each other and with infrastructure like traffic lights and road signs. This connectivity will enable coordinated movements and real-time traffic management, reducing the likelihood of accidents and improving overall traffic flow. Moreover, the widespread adoption of autonomous vehicles could lead to significant changes in urban planning and infrastructure. With fewer parking spaces needed, cities could repurpose land for parks, pedestrian zones, and other community amenities. Autonomous vehicles could also enable the development of new transportation models, such as personal rapid transit systems and autonomous public transportation networks, making it easier for people to move around without relying on private cars. Number 10. Swarm Robotics. Swarm robotics represents a cutting-edge approach in the field of robotics, inspired by the collective behavior observed in nature, such as flocks of birds, schools of fish, and colonies of ants. This innovative technology involves the coordination of multiple robots working together to achieve tasks that would be impossible or inefficient for a single robot to accomplish. One of the key advancements in swarm robotics is the development of sophisticated algorithms that enable seamless communication and coordination among robots. These algorithms allow each robot in the swarm to make autonomous decisions based on local information while contributing to the collective goal. This decentralized approach ensures that the swarm can adapt to changing environments and tasks without relying on a central controller. For instance, researchers have created swarms of drones that can autonomously explore and map complex terrains, such as forests or disaster-stricken areas, providing critical data for rescue operations or environmental studies. In agriculture, swarm robotics is making significant strides. Swarms of small, lightweight robots can be deployed to monitor crops, assess soil health, and perform precision farming tasks like planting seeds, applying fertilizers, or removing weeds. These robots can work around the clock, covering large areas more efficiently than human laborers. By providing real-time data and precise interventions, swarm robotics can enhance crop yields, reduce the use of chemicals, and promote sustainable farming practices. Environmental monitoring is another area where swarm robotics is showing great promise. Swarms of aquatic robots, for example, can be used to monitor water quality in oceans, lakes, and rivers. These robots can collect data on pollution levels, temperature, and marine life, helping scientists understand and address environmental issues. Similarly, aerial swarms can monitor air quality, track wildlife populations, and assess the health of ecosystems. The ability to gather and analyze vast amounts of data from multiple sources simultaneously makes swarm robotics an invaluable tool for environmental conservation. In disaster response, swarm robotics can play a crucial role in search and rescue missions. Swarms of drones or ground robots can quickly spread out over a disaster area, locating survivors, assessing damage, and delivering supplies. Their ability to navigate through rubble and hazardous environments makes them ideal for situations where human responders might be at risk. For example, in the aftermath of an earthquake, swarm robots could enter collapsed buildings to search for trapped individuals, providing real-time information to rescue teams and increasing the chances of successful recoveries. The manufacturing industry is also set to benefit from swarm robotics. In smart factories, swarms of robots can work together to assemble products, perform quality control, and manage inventory. These robots can communicate with each other to coordinate tasks, optimize workflows, and ensure that production lines run smoothly. By reducing downtime and increasing efficiency, swarm robotics can enhance productivity and lower operational costs. Moreover, the flexibility of swarm robots allows them to be easily reconfigured for different tasks, making them ideal for dynamic and adaptive manufacturing environments. Looking into the future, swarm robotics is expected to become even more advanced and integrated into various sectors. As artificial intelligence and machine learning technologies continue to evolve, swarm robots will gain enhanced decision-making capabilities, allowing them to handle more complex tasks with greater autonomy. The miniaturization of robotics components will enable the development of even smaller and more agile robots, capable of accessing hard-to-reach areas and performing delicate operations. Additionally, advancements in energy storage and wireless communication will extend the operational range and duration of swarm robots. This will enable them to undertake longer missions and operate in remote or challenging environments without the need for frequent recharging or human intervention. The integration of swarm robotics with other emerging technologies, such as the Internet of Things and 5G networks, will further enhance their capabilities and applications. Number 11. Exoskeletons. Exoskeletons represent a remarkable advancement in robotics, offering transformative potential across various fields, including healthcare, industrial labor, and military applications. These wearable robotic devices are designed to augment human capabilities by providing additional strength, endurance, and mobility. One of the most exciting current advancements in exoskeleton technology is its application in the healthcare sector, particularly in rehabilitation and mobility assistance. Exoskeletons like the ReWalk and ExoBionic systems are designed to help individuals with spinal cord injuries or lower limb disabilities to stand, walk, and even climb stairs. These devices use sensors and motors to mimic natural movements, allowing users to regain mobility and independence. By providing support and enhancing physical capabilities, exoskeletons can significantly improve the quality of life for people with disabilities, offering new opportunities for rehabilitation and daily activities. In industrial settings, exoskeletons are being developed to reduce physical strain and prevent injuries among workers. Companies like Sarcos Robotics and Lockheed Martin are creating powered exoskeletons that assist with heavy lifting and repetitive tasks. These devices are designed to distribute weight and provide support to the wearer's muscles and joints, reducing the risk of musculoskeletal disorders and fatigue. By enhancing the strength and endurance of workers, industrial exoskeletons can improve productivity, safety, and overall job satisfaction. For example, warehouse workers equipped with exoskeletons can handle heavier loads with ease, reducing the need for additional manpower and minimizing the risk of injury. The military and defense sector is also exploring the potential of exoskeleton technology to enhance the capabilities of soldiers. Exoskeletons like the Onyx system by Lockheed Martin are being developed to provide additional strength, endurance, and protection to military personnel. These devices can help soldiers carry heavier equipment, traverse rough terrains, and maintain high levels of performance for extended periods. By augmenting physical capabilities, military exoskeletons can improve operational effectiveness and reduce the risk of injury in combat situations. Looking into the future, exoskeleton technology is expected to evolve significantly, becoming more sophisticated, versatile, and accessible. Advances in materials science, robotics, and artificial intelligence will drive the development of lighter, more flexible, and more intuitive exoskeletons. Future exoskeletons could incorporate smart materials that adapt to the wearer's movements and provide personalized support, enhancing comfort and usability. One exciting area of development is the integration of advanced sensors and AI algorithms to create more responsive and adaptive exoskeletons. These devices could use real-time data from the wearer's body and environment to adjust their assistance levels dynamically. For instance, an exoskeleton could detect when the wearer is lifting a heavy object and automatically provide additional support, reducing strain on the muscles and joints. This level of adaptability could make exoskeletons even more effective in various applications, from healthcare and industrial labor to sports and rehabilitation. The potential for exoskeletons to enhance human performance extends beyond physical capabilities. Researchers are exploring the possibility of integrating exoskeletons with neural interfaces, allowing users to control the devices with their thoughts. This could enable more seamless and intuitive interaction between the wearer and the exoskeleton, further enhancing mobility and dexterity. Such advancements could be particularly beneficial for individuals with severe disabilities, providing new avenues for rehabilitation and independence. Moreover, the widespread adoption of exoskeletons could have significant societal and economic impacts. In healthcare, exoskeletons could reduce the burden on caregivers and healthcare systems by enabling individuals to perform daily activities independently. In industrial settings, exoskeletons could improve worker safety and productivity, leading to cost savings and increased efficiency. The military could benefit from enhanced soldier performance and reduced injury rates, improving overall mission effectiveness. Number 12. Robotic chefs. Robotic chefs are poised to revolutionize the culinary world, bringing automation and precision to kitchens in homes, restaurants, and commercial food production facilities. These advanced robots are designed to perform a wide range of cooking tasks, from chopping and mixing ingredients to cooking and plating dishes with exceptional consistency and speed. One of the most notable advancements in robotic chefs is the development of fully automated cooking systems. Companies like Robotics have introduced robotic kitchen units equipped with robotic arms that mimic the movements of human chefs. These systems can prepare a wide variety of dishes by following recipes stored in their databases. The robotic arms can chop vegetables, stir pots, and even handle delicate tasks like cracking eggs. High-definition cameras and sensors allow these robots to recognize and interact with different ingredients and cooking tools, ensuring precision and consistency in every dish. The ability to replicate the skills of top chefs means that these robots can produce restaurant-quality meals at home, offering convenience and culinary excellence. Another significant advancement is the integration of AI and machine learning in robotic chefs. AI algorithms enable these robots to learn from their experiences, adapt to user preferences, and even create new recipes. For example, the Flippy robot by Robotics is an AI-powered robotic arm used in commercial kitchens to grill burgers, fry chicken, and perform other cooking tasks. Flippy can analyze data from sensors and cameras to adjust cooking times and temperatures in real time, ensuring that food is cooked to perfection. The use of AI allows robotic chefs to personalize meals based on dietary restrictions, nutritional needs, and individual tastes, providing a customized dining experience. Robotic chefs are also making their way into the fast food industry, where speed and efficiency are paramount. Robots like Spice's robotic kitchen can prepare complex meals in a matter of minutes, reducing wait times and increasing throughput in busy restaurants. These systems automate the entire cooking process, from ingredient preparation to final plating, allowing for consistent quality and rapid service. The ability to quickly and efficiently produce high-quality meals can help fast food restaurants meet the demands of their customers while maintaining high standards of food safety and hygiene. In the future, robot chefs will revolutionize the restaurant industry, particularly in major fast food chains, by automating many of the tasks currently handled by kitchen staff. Equipped with precision robotics, AI-driven cooking algorithms, and the ability to prepare meals quickly and consistently, these robotic systems will dominate fast food kitchens, streamlining operations and improving efficiency. From flipping burgers to assembling complex dishes, robot chefs will handle the repetitive, high-volume tasks with ease, reducing the need for human workers in these roles. As the technology matures, we may also see robot chefs being adopted by other types of restaurants, including casual dining and even upscale establishments. This shift will not only reduce labor costs, but also enhance food safety and quality control, as the robots will be able to monitor and adjust cooking processes with extreme accuracy. While fewer kitchen staff may be required, the need for maintenance, programming, and oversight of these advanced machines will create new roles in the culinary tech space, transforming how restaurants operate and deliver food to customers. Number 13. Surgical robots. Surgical robots have made remarkable strides in recent years, transforming the landscape of medical procedures with their precision, flexibility, and minimally invasive capabilities. These advancements are not only enhancing the outcomes of surgeries, but also expanding the possibilities of what can be achieved in the operating room. One of the most notable advancements in surgical robotics is the development of the Da Vinci surgical system, which has become the benchmark for robotic-assisted surgeries. This system consists of a surgeon's console, patient-side robotic arms, and high-definition 3D vision. The surgeon operates the console, translating their hand movements into precise micro-movements of the robotic instruments. This technology allows for greater precision and control than traditional manual surgery, enabling surgeons to perform complex procedures with smaller incisions, resulting in less pain, reduced risk of infection, and faster recovery times for patients. Another exciting development is the emergence of autonomous and semi-autonomous surgical robots. These robots are equipped with advanced artificial intelligence and machine learning algorithms that allow them to assist surgeons by performing specific tasks autonomously. For example, researchers have developed robots capable of sewing incisions with precision, reducing the time needed for this critical step and improving the consistency of the results. As these technologies advance, the role of AI in surgery is expected to grow, potentially leading to robots that can perform entire procedures with minimal human intervention. In the future, surgical robots are expected to become even more sophisticated and widely adopted. One area of potential growth is the development of microsurgical robots capable of operating at the cellular and molecular levels. These robots could perform intricate procedures, such as repairing nerve damage or performing targeted cancer treatments with unparalleled precision. The ability to manipulate tissues at such a fine scale could open new avenues for treating conditions that are currently difficult or impossible to address surgically. Another exciting possibility is the use of surgical robots in remote and telesurgery. With advancements in communication technologies and robotics, surgeons could perform procedures on patients located in different parts of the world. This would be particularly beneficial for patients in remote or underserved areas who might not have access to specialized surgical expertise. Telesurgery could also facilitate collaboration between surgeons, allowing experts to guide and assist each other in real time, regardless of their physical locations. The ongoing miniaturization of robotic components is likely to lead to the development of smaller, more versatile surgical robots. These compact robots could be used in minimally invasive procedures, entering the body through natural orifices or small incisions to perform surgeries with minimal disruption to surrounding tissues. This would further reduce recovery times and improve patient comfort, making surgical interventions less daunting and more accessible. Furthermore, the integration of real-time data analytics and machine learning into surgical robots could enhance their adaptability and performance. By continuously analyzing data from sensors and patient monitoring systems, these robots could adjust their actions in real time to optimize outcomes. This could lead to more personalized and precise surgical interventions, tailored to the specific needs and conditions of each patient. Number 14. Industrial automation robots. Industrial automation robots have seen remarkable advancements in recent years, significantly transforming the manufacturing landscape. These robots are designed to perform tasks with high precision, speed, and consistency, making them invaluable assets in various industries. One of the most notable advancements in industrial automation robots is the development of collaborative robots, or cobots. Unlike traditional industrial robots that operate in isolated environments, cobots are designed to work alongside human workers, enhancing productivity and safety. These robots are equipped with advanced sensors and AI algorithms that allow them to detect human presence, avoid collisions, and adapt to their surroundings. Cobots can perform a range of tasks, from assembly and packaging to quality inspection and machine tending. Their ability to work collaboratively with humans opens up new possibilities for flexible and efficient production lines. Another exciting development is the integration of AI and machine learning in industrial robots. These technologies enable robots to learn from their experiences and improve their performance over time. For instance, AI-powered robots can analyze data from sensors and cameras to identify defects in products, predict maintenance needs, and optimize production schedules. This self-learning capability allows robots to handle complex tasks with greater accuracy and efficiency, reducing downtime and improving overall productivity. In addition, AI enables robots to adapt to changes in the production environment, making them more versatile and capable of handling a wider variety of tasks. The advancement of vision systems is also a significant milestone in industrial automation. Modern industrial robots are equipped with sophisticated vision systems that allow them to see and interpret their environment with high precision. These vision systems use cameras and sensors to capture detailed images and data, which are then processed by AI algorithms to recognize objects, measure dimensions, and detect anomalies. This capability is particularly useful in quality control and inspection processes, where robots can identify defects and ensure that products meet stringent standards. Vision-enabled robots can also perform tasks such as sorting, picking, and placing with high accuracy, enhancing the efficiency of manufacturing operations. In the future, industrial automation robots are expected to become even more advanced and integrated into various production processes. One area of potential growth is the development of mobile robots that can navigate autonomously within factories and warehouses. These robots, equipped with advanced sensors and AI, can transport materials, manage inventory, and assist with logistics, reducing the need for manual labor and streamlining operations. The ability to move autonomously and perform tasks on the go will make these robots indispensable in dynamic and fast-paced industrial environments. Another promising advancement is the use of robotics in additive manufacturing, or 3D printing. Robots can be used to automate the 3D printing process, from loading materials to post-processing and assembly. The evolution of industrial automation robots will also be driven by advancements in connectivity and the industrial Internet of Things. By connecting robots to a network of sensors, devices, and systems, manufacturers can gain real-time insights into production processes, optimize workflows, and enhance predictive maintenance. Number 15. Construction robots. Construction robots are poised to revolutionize the building industry, introducing unprecedented levels of efficiency, safety, and precision. These robots are designed to perform a variety of tasks, from bricklaying and concrete printing to demolition and site inspection. One of the most notable advancements in construction robotics is the development of autonomous bricklaying robots. Robots like the semi-automated mason by Construction Robotics can lay bricks significantly faster than human workers. This robot uses a combination of robotic arms, sensors, and AI to pick up bricks, apply mortar, and place them with precision. This not only speeds up the construction process, but also ensures consistency and quality, reducing the likelihood of human error. By automating repetitive and labor-intensive tasks, these robots can help address labor shortages in the construction industry and improve overall productivity. In the future, construction robots equipped with advanced general intelligence could transform the way buildings are designed and constructed. These autonomous robots could have the capability to manage entire building projects from start to finish, significantly reducing the need for human labor. By leveraging 3D printing technology, they will be able to construct complex structures with high precision, laying the groundwork for everything from homes to skyscrapers. With the ability to autonomously assess project requirements, adjust designs in real time, and optimize material usage, these robots could streamline the construction process while minimizing waste and reducing costs. 15 future megaprojects will change the world forever, and they might become a reality much sooner than you'd expect. For example, smart cities. Smart cities are set to redefine urban living, blending cutting-edge technology with city infrastructure to create efficient, sustainable, and highly connected environments. Imagine cities where everything is interconnected. A central network tracks the location of all electric vehicles and flying drones in real time, using sensors and AI to manage traffic flow and ensure safety. Traffic lights in these cities are no longer static, but respond dynamically, reducing congestion by adjusting to the real-time flow of vehicles and pedestrians. This level of responsiveness aims to create an urban environment where delays and traffic jams are minimized, making the daily commute smoother and faster. Autonomous vehicles are a central feature of these smart cities, constantly communicating with each other to optimize traffic. Cars, buses, and trucks equipped with advanced sensors and communication systems share data on their speed, location, and intended route. This coordination allows vehicles to anticipate each other's actions, reducing the risk of accidents and improving overall efficiency. Imagine a city where traffic lights are almost obsolete because vehicles know when to stop, start, and merge seamlessly, avoiding sudden stops or traffic buildup. This interconnected system would not only optimize traffic flow, but also reduces emissions and makes travel safer. In addition to autonomous vehicles, the infrastructure in these cities would support a fleet of robo-taxis that are always available and can be requested through a mobile app. These electric, self-driving taxis make urban transport accessible, convenient, and environmentally friendly, catering to both residents and visitors. Smart city infrastructure is designed to support these robo-taxis with dedicated charging stations and optimized routes, ensuring that they are efficient and widely available. Security in smart cities would be significantly enhanced through advanced AI-powered surveillance systems. High-tech networks of cameras, sensors, and analytics software could monitor public areas, identifying potential threats and notifying authorities in real time. Robots equipped with cameras and sensors could even patrol public areas, ensuring safety and monitoring for unusual activity. While such surveillance would raise important discussions around privacy, its potential to reduce crime and improve public safety could be substantial. Make sure to stick around to the end because this video explores Hyperloop networks, Zeta-scale supercomputers, the Very Large Hadron Collider, fusion power plants, arcologies, artificial islands, and more. Number 2. Space elevators. Space elevators are among the most visionary megaprojects that could completely transform how humanity accesses space. Imagine a giant cable stretching from Earth's surface into orbit, allowing vehicles to smoothly ascend and descend without the explosive energy needed for rocket launches. The space elevator concept involves a tether anchored to the ground and extending far beyond geostationary orbit, where it is balanced by a counterweight. Along this tether, specialized climbers would carry cargo and passengers, offering a vastly more cost-effective and energy-efficient way to reach space. This technology could change space travel from an extraordinary event to a routine operation. The potential advantages of a space elevator are profound. Currently, rockets are the only means to send payloads to space, but they are expensive, fuel-hungry, and produce significant pollution. A space elevator, in contrast, could dramatically reduce launch costs, possibly by a factor of 100, and eliminate the need for massive amounts of chemical propellant. The climbers on a space elevator could be powered by electric energy, making the entire process more sustainable and environmentally friendly. This cost reduction and green technology could open the door to large-scale space construction projects, lunar mining, and even human colonization of other celestial bodies. With a space elevator, we could transport entire segments of space stations, build solar power arrays in orbit, and facilitate the rapid movement of people and materials. Such a system would allow frequent, reliable access to space, something that is currently limited by the high costs and complexities of rocket launches. It could transform space from a frontier accessible only to well-funded national agencies and billionaires into a domain open to broader economic development and scientific research. Of course, the challenges are immense. The tether material needs to be stronger than anything we have today, ideally using advanced materials like carbon nanotubes or graphene. Creating such a material and ensuring it can be produced at scale remains a significant hurdle. The risk of collisions with satellites or space debris also poses a threat, necessitating sophisticated tracking and avoidance systems. Despite these challenges, the vision of a space elevator remains compelling. If humanity can solve the technical problems, it could revolutionize our relationship with space, making it cheaper, cleaner, and more accessible. Number 3. Arcologies. Arcologies are futuristic megastructures that aim to combine architecture and ecology into self-sustaining urban habitats. Imagine entire cities contained within massive vertical buildings, designed to be compact, efficient, and capable of housing tens of thousands of people while maintaining a minimal ecological footprint. Arcologies are designed to provide everything a community needs: homes, workplaces, entertainment, and green spaces, all in one interconnected structure. The goal is to address the challenges of overpopulation, urban sprawl, and environmental degradation by creating dense, sustainable communities that coexist harmoniously with the environment. One of the most fascinating aspects of arcologies is their focus on self-sufficiency. These megastructures would integrate renewable energy systems, vertical farms, and water recycling technologies to minimize their reliance on external resources. By using advanced vertical farming methods, arcologies could grow enough food within their walls to sustain residents, cutting down on the need for transport and reducing carbon emissions. This level of efficiency makes arcologies a potentially revolutionary answer to both the housing crisis and the pressing need for sustainable urban development. Arcologies also represent a bold reimagining of urban life. Instead of sprawling cities that require extensive commuting, these structures would make all essential services accessible within walking distance. By minimizing the need for cars, arcologies could significantly reduce traffic congestion and air pollution, creating a cleaner, healthier environment for inhabitants. This compact living model could also foster a greater sense of community, as people would live and work in closer proximity, promoting social interaction and reducing the isolation that can sometimes occur in large urban areas. Number 4. Hyperloop transportation networks. Imagine being able to travel between major cities at speeds exceeding 700 miles per hour, all while gliding through a vacuum-sealed tube with minimal friction. Originally proposed by Elon Musk, the Hyperloop promises to make that vision a reality, using advanced technology to drastically reduce travel times and improve connectivity. The technology behind Hyperloop involves sealed tubes with very low air pressure, allowing specially designed pods to move with minimal resistance. Electromagnetic propulsion systems and air bearings allow these pods to achieve ultra-high speeds in a smooth, almost frictionless environment. Because of its unique design, Hyperloop is capable of outpacing traditional forms of transportation, including high-speed trains and airplanes. When it comes to efficiency and energy consumption, it aims to offer a sustainable solution that uses less energy and has a smaller carbon footprint compared to conventional transportation methods. One of the most compelling aspects of Hyperloop is its potential to drastically alter the landscape of urban commuting and intercity travel. Imagine traveling from Los Angeles to San Francisco in under an hour, or from Washington, D.C. to New York City in just minutes. The Hyperloop could effectively shrink distances, making it possible for people to work in one city and live in another without spending hours on the road or in the air. This level of connectivity could revolutionize how we think about city planning, job opportunities, and even real estate, making once distant places easily accessible. Number 5. Zetascale supercomputers. Zetascale supercomputers are the next frontier in computing power, set to revolutionize science, industry, and technology by achieving computational capabilities that are 1,000 times greater than today's most advanced exascale supercomputers. These futuristic machines could perform an astonishing 1 sextillion calculations per second. That's 10, followed by 21 zeros every single second. This level of power would redefine what's possible in fields ranging from climate modeling to medicine and artificial intelligence. Imagine a supercomputer with the processing capacity to solve in minutes what would take current systems years to complete. That's the transformative promise of zetascale computing. One of the most exciting applications of zetascale supercomputers is in understanding and mitigating climate change. With this level of processing power, scientists could create ultra-detailed climate models that simulate complex atmospheric, oceanic, and land interactions with unparalleled accuracy. These simulations could provide better predictions of climate trends and help formulate effective global responses to environmental challenges. Additionally, zettascale power could revolutionize the development of renewable energy systems by optimizing the design and deployment of wind farms, solar arrays, and smart grids. In medicine, zettascale computing could fast-track breakthroughs in personalized healthcare. By processing and analyzing vast amounts of genetic, clinical, and lifestyle data, these supercomputers could develop individualized treatment plans tailored to a person's specific genetic makeup and health history. This could lead to more effective therapies for diseases like cancer, Alzheimer's, and other complex conditions that have eluded conventional treatments. Artificial intelligence would also reach new heights with zettascale computing. AI systems could be trained on incredibly large data sets in a fraction of the time it takes today, resulting in more advanced machine learning models with greater understanding and reasoning abilities. From autonomous vehicles to smart cities, the applications of AI powered by zettascale processing would be virtually limitless. While building a zettascale supercomputer poses significant challenges, particularly in terms of energy consumption and cooling, ongoing advancements in quantum computing, new materials, and energy-efficient architectures are bringing this ambitious goal closer to reality. Number 6. Fusion power plants. Fusion power plants represent the pinnacle of human ingenuity and ambition. Imagine harnessing the same force that powers the sun, nuclear fusion, to produce clean, nearly unlimited energy here on Earth. Unlike the nuclear fission reactors we currently use, which split heavy atoms to release energy, fusion involves combining light atoms, like hydrogen, under extreme pressure and temperature to create helium, releasing vast amounts of energy in the process. What makes fusion so compelling is that it produces minimal radioactive waste and carries no risk of a catastrophic meltdown, offering a much safer alternative to conventional nuclear power. The potential benefits of fusion are game-changing. Fusion power promises a sustainable, virtually limitless energy source because its primary fuel, hydrogen isotopes, can be easily extracted from seawater. Unlike fossil fuels, which are finite and contribute heavily to climate change, fusion emits no greenhouse gases. This means that fusion could drastically reduce carbon emissions, playing a crucial role in mitigating global climate change. Additionally, fusion doesn't face the reliability issues of renewable sources like wind and solar, which depend on weather conditions. It provides a stable, round-the-clock supply of energy that could revolutionize global power systems. Despite its promise, achieving functional fusion power is one of the greatest scientific and engineering challenges humanity faces. For fusion to occur, reactors need to reach temperatures of over 100 million degrees Celsius, conditions hotter than the core of the sun. This requires state-of-the-art technologies, like magnetic confinement, to contain the superheated plasma where fusion reactions occur. ITER, an international megaproject currently under construction in France, aims to prove that large-scale fusion is feasible. If successful, ITER will pave the way for commercial fusion reactors that could meet humanity's energy needs indefinitely. Fusion power plants, once operational, could change the world by providing a clean, abundant, and sustainable energy supply. They offer a future where energy scarcity is a thing of the past, and our reliance on polluting fossil fuels is drastically reduced. Number 7. The Very Large Hadron Collider. Building on the success of CERN's Large Hadron Collider, the Very Large Hadron Collider would be a massive particle accelerator, far bigger and more powerful than its predecessor. Stretching over hundreds of kilometers, this collider would accelerate particles to even higher energies, allowing scientists to explore the deepest mysteries of physics, such as the nature of dark matter, the existence of extra dimensions, and the fundamental forces that hold the universe together. This massive collider would provide an opportunity to discover new particles and phenomena that the current Large Hadron Collider simply cannot reach. The knowledge gained from smashing particles together at unprecedented speeds would not only expand our understanding of the universe, but could also lead to breakthroughs in technology, medicine, and material science. Building such an enormous machine would also push the limits of engineering, requiring innovations in superconducting magnets, energy storage, and ultra-precise measurement techniques. While this collider is still in the conceptual phase and faces challenges related to cost and feasibility, the potential scientific rewards make it an incredibly enticing prospect. If constructed, it could be the key to answering some of the most profound questions about our universe, taking humanity one step closer to unlocking the ultimate secrets of existence. Number 8. Artificial islands. Artificial islands are among the most ambitious megaprojects being explored to address the growing challenges of urban expansion, land scarcity, and rising sea levels. These large-scale land reclamation projects involve creating new landmasses from the ocean, providing opportunities for urban development, tourism, and even agriculture. Utilizing advanced engineering techniques and sustainable practices, artificial islands offer a bold vision for expanding habitable and productive space in densely populated areas. One of the most compelling aspects of artificial islands is their potential to alleviate land scarcity in coastal cities. As urban populations swell, cities are struggling to find the space needed for housing, infrastructure, and green areas. By building artificial islands, countries can expand their urban landscapes without encroaching on existing natural habitats or farmland. This makes them particularly attractive for cities like Tokyo, Dubai, and Singapore, where available land is limited and the demand for space is high. In addition to urban expansion, artificial islands have become popular tourist destinations. Projects like Dubai's Palm Jumeirah are famous for their luxurious resorts, beautiful beaches, and unique architecture, making them a draw for international visitors. These islands can boost local economies by attracting tourism and investment, creating jobs, and stimulating growth. Artificial islands could also be used for agriculture, employing innovative techniques like vertical farming to create food sources close to urban centers, reducing the carbon footprint of food transportation. However, creating artificial islands is not without challenges. The environmental impact of these projects can be significant, including disruption of marine ecosystems, increased coastal erosion, and pollution. Furthermore, the high costs associated with constructing and maintaining artificial islands mean they are often accessible only to wealthier nations or private investors. Despite these challenges, the potential benefits, such as addressing land scarcity and adapting to rising sea levels, make artificial islands an exciting concept for the future. Number 9. The Extremely Large Telescope. The Extremely Large Telescope is set to become one of the most powerful astronomical tools ever built, poised to revolutionize our understanding of the universe. With plans to be located high in the Atacama Desert of Chile, this telescope will feature a massive 39-meter primary mirror, making it the largest optical and infrared telescope in the world. Its enormous size and cutting-edge technology will allow it to capture detailed images of distant celestial objects that have previously been beyond our reach, enabling astronomers to peer deeper into space than ever before. One of the most exciting possibilities of the Extremely Large Telescope is its potential to help answer some of the biggest questions in astronomy. The telescope's powerful optics will allow scientists to directly observe exoplanets, planets orbiting stars outside our solar system, with unprecedented clarity. By studying these distant worlds, astronomers hope to determine whether they have atmospheres capable of supporting life. This telescope could even detect the chemical signatures of biological activity, bringing us closer to finding evidence of extraterrestrial life. It will also be instrumental in exploring the origins of the universe. Its ability to observe the faint light from the earliest stars and galaxies could provide crucial insights into the formation of cosmic structures after the Big Bang. This information will help scientists piece together the complex history of the universe, shedding light on how galaxies like our own Milky Way were formed and how they have evolved over billions of years. Another major goal of this telescope is to study dark matter and dark energy, mysterious components that make up most of the universe but remain largely unknown. The Extremely Large Telescope's powerful capabilities will help map the distribution of dark matter by observing the way it influences the motion of galaxies and the bending of light. Additionally, the telescope will contribute to understanding dark energy, the force driving the accelerated expansion of the universe, providing data that could change our fundamental theories of physics. Number 10. Earth scrapers. Earth scrapers are an exciting and innovative concept that flips the traditional skyscraper model upside down. Instead of towering above the ground, earth scrapers extend deep below the surface, creating vast underground urban spaces that could redefine how we think about city living. Designed to tackle the challenges of urban overcrowding, land scarcity, and environmental impact, earth scrapers could house entire communities, complete with homes, offices, green spaces, and amenities, all beneath the city streets. By building downwards, these structures offer a way to expand urban space without altering city skylines or encroaching on natural habitats. One of the most compelling aspects of earth scrapers is their potential for sustainability. Building underground provides natural insulation, reducing the energy required for heating and cooling. The Earth's surrounding temperature remains relatively constant, making these structures energy efficient and environmentally friendly. Moreover, earth scrapers can incorporate green technologies like geothermal energy, solar panels, and advanced ventilation systems to ensure a comfortable and sustainable living environment for inhabitants. By integrating vertical gardens and shared green spaces, earth scrapers can also help enhance the quality of life, offering a refuge from the hustle and bustle of city life above. Earth scrapers could also help preserve a city's cultural heritage. Many urban centers face the challenge of balancing modernization with the preservation of historical sites. By building downwards, cities can continue to grow without demolishing existing landmarks or changing the visual character of their iconic skylines. Additionally, by using the underground space for commercial, residential, or recreational purposes, earth scrapers free up above-ground areas for parks, pedestrian zones, and other public amenities that can enhance urban life. While constructing an earth scraper presents engineering challenges, such as ensuring proper lighting, ventilation, and structural integrity, advancements in construction technology are bringing these ambitious projects closer to reality. If successful, earth scrapers could become a revolutionary way to expand urban environments, making cities more sustainable, efficient, and enjoyable for everyone. Number 11. Massive reforestation projects. Massive reforestation projects are among the most impactful megaprojects that could reshape the future of our planet. Imagine initiatives spanning entire continents, dedicated to planting billions of trees to restore the world's forests. These efforts are crucial for combating climate change, preserving biodiversity, and revitalizing degraded ecosystems. By planting trees on a massive scale, we can absorb large amounts of carbon dioxide from the atmosphere, making reforestation an essential part of the solution to global warming. Reforestation doesn't just address climate change, it also plays a pivotal role in preserving biodiversity. Forests are home to over 80% of the world's terrestrial species, from plants and insects to birds and mammals. By restoring forest habitats, we give countless species the chance to recover and thrive, helping to reverse the alarming rate of extinction we face today. Additionally, forests play a key role in maintaining ecosystem services, such as water purification, soil conservation, and flood regulation, all of which directly benefit local communities. One of the most exciting aspects of massive reforestation is the broad coalition of support it enjoys. Governments, private companies, and non-profit organizations have all thrown their weight behind these initiatives, resulting in projects like the Great Green Wall in Africa, which aims to restore degraded lands across 11 countries. This global support makes reforestation one of the most feasible large-scale environmental projects capable of uniting people around a common goal of planetary healing. Number 12. The Boring Company's tunnel networks. The Boring Company's tunnel networks are set to redefine urban transportation by taking traffic underground, providing an innovative solution to congestion and inefficiency in modern cities. Founded by Elon Musk, the Boring Company aims to create an extensive underground system of tunnels for autonomous electric vehicles and high-speed transit, ultimately reducing the burden on surface roads. Imagine being able to bypass rush-hour traffic entirely, cruising through a tunnel network below the city that whisks you to your destination smoothly and without delay. One of the main problems these tunnel networks address is surface traffic congestion. Major cities worldwide are grappling with the problems of traffic jams, which lead to wasted time, increased pollution, and frustrated commuters. By building a network of underground tunnels dedicated to electric vehicles, the Boring Company hopes to alleviate pressure from above-ground streets. This is particularly advantageous for densely populated urban areas, where expanding road capacity horizontally is no longer feasible. Underground tunnel networks offer a third dimension to transportation, one that doesn't interfere with existing city infrastructure or disrupt neighborhoods. These tunnels would accommodate autonomous electric vehicles, including modified Teslas, capable of moving through these tunnels at high speeds. The concept envisions people commuting in autonomous cars that zip below the city, free from traffic lights or obstacles. The absence of traditional cars, buses, and trucks means these tunnels can be designed for highly efficient, streamlined transit, potentially reducing travel times significantly. High-speed transit options such as sleds or Hyperloop-like pods could also be implemented, making it possible to travel across cities or even between neighboring cities in a fraction of the time it takes today. While the technology and concept are promising, there are challenges to overcome. Scalability and cost remain significant hurdles. Digging tunnels, even with advanced boring machines, is costly, and scaling these networks across an entire city or country requires substantial investment and planning. However, if successful, these tunnel networks could reshape urban transportation, making it faster, more efficient, and less environmentally impactful. Number 13. Smart grid technology. Smart grid technology represents a transformative shift in how we generate, distribute, and consume electricity. Unlike traditional grids, which are often outdated and inefficient, smart grids are designed to incorporate digital communication technology, sensors, and real-time data analysis to make the power supply more reliable and efficient. This integration enables the grid to respond intelligently to fluctuations in demand, helping prevent outages, optimize energy use, and incorporate renewable energy sources more effectively. One of the key features of smart grids is their ability to integrate diverse renewable energy sources, such as solar panels and wind turbines, into the existing power network. Traditional grids struggle to manage the variability of renewable energy. The sun doesn't always shine, and the wind doesn't always blow. However, smart grids can balance these fluctuations with real-time adjustments, ensuring a steady supply of electricity. This capability is crucial for reducing our reliance on fossil fuels and making the shift towards a greener, more sustainable energy system. Another compelling aspect of smart grid technology is its potential to empower consumers. Smart meters, which are a central part of the smart grid, provide users with detailed information about their energy consumption. This data allows individuals to adjust their usage habits, save on energy bills, and make more informed choices about how they use electricity. In the future, households might even become prosumers, producing their own electricity via solar panels and selling surplus energy back to the grid, fostering a decentralized energy system. Smart grids also enhance grid security and resilience. By incorporating advanced sensors and automation, these grids can quickly detect and respond to problems such as power surges or equipment failures, reducing the risk of widespread outages. This makes smart grids particularly important, as the world faces an increasing number of climate-related disasters that put stress on existing power infrastructure. Number 14. Global carbon capture and storage systems. These systems could be one of the most transformative megaprojects of our time, providing a crucial tool for mitigating the impacts of climate change. They're designed to capture carbon dioxide emissions directly from industrial sources, such as power plants and factories, preventing them from being released into the atmosphere. Once captured, the carbon dioxide can either be stored deep underground in geological formations or repurposed for use in various industrial processes, such as enhancing oil recovery or even creating synthetic fuels. The significance of carbon capture and storage systems lie in their potential to drastically reduce the levels of CO2, one of the main drivers of global warming, in the atmosphere. While renewable energy sources like solar and wind are key to transitioning to a greener future, Many industries still rely on fossil fuels and continue to emit substantial amounts of carbon. These systems offer a way to bridge this gap, allowing us to curb emissions while renewable infrastructure is expanded. It is particularly important for hard-to-decarbonize sectors like cement, steel, and chemical manufacturing, where emissions are difficult to eliminate using renewable energy alone. Once the carbon is captured, it must be safely stored. Most plans involve injecting CO2 deep into underground rock formations, often in depleted oil or gas fields, where it can be stored permanently. This storage process is designed to be secure, ensuring that the gas does not leak back into the atmosphere. There are also efforts to repurpose captured carbon, turning it into products like carbonated drinks, construction materials, or even synthetic fuels, which could provide economic incentives to further invest in this technology. Despite its promise, large-scale implementation of these systems faces economic and technical barriers. The infrastructure required to capture, transport, and store carbon is costly, and questions remain about who will bear these expenses. Additionally, transporting CO2 from its source to storage sites requires an extensive pipeline network, which poses logistical challenges. However, with increasing support from governments and private industries, the feasibility of these systems is becoming more realistic. Number 15. Massive desalination plants. Massive desalination plants could be the game changer we need to solve the world's freshwater crisis. These gigantic facilities are designed to convert seawater into potable water, providing a reliable supply for regions suffering from chronic water scarcity. With nearly 2/3 of the global population facing water shortages, desalination offers a promising solution to meet the needs of growing populations, particularly in arid areas where freshwater sources are limited or overused. By transforming vast oceans into drinkable water, desalination plants offer a hopeful vision of abundant water in places where it's currently a rare commodity. One of the most significant benefits of massive desalination projects is their ability to support large populations living in dry regions. Countries like Saudi Arabia, Israel, and Australia are already leveraging desalination to address their water needs, and these efforts could expand even further to make a global impact. Large-scale desalination could ensure that even the most water-stressed communities have access to safe, clean drinking water, reducing dependency on dwindling rivers and lakes. This could improve health outcomes, boost agricultural productivity, and even help alleviate regional conflicts over water resources. Advancements in technology are also making desalination more feasible and appealing. Traditional desalination methods have been energy-intensive, often criticized for their high environmental footprint. However, recent innovations, such as reverse osmosis improvements and renewable energy-powered desalination, are helping to cut down on energy use and emissions. Solar and wind-powered desalination plants are particularly promising, offering a sustainable way to create fresh water without exacerbating climate change. Massive desalination plants hold the key to addressing one of humanity's most pressing challenges, ensuring a stable water supply for all. By turning the oceans into a source of life, these megaprojects could reshape how we approach water sustainability, giving future generations the chance to thrive, even in a world with growing climate and population pressures. Thanks for watching. Make sure to watch this next video about the future of technology.